We sent out 60 invitations for all the companies that have done work here in Surrey County or their companies are based here in Surrey County. I think we have over 20 companies that have responded and been here, so that's outstanding. That's really proud of that. We have more people than we do have for our general contractors class in June. We usually have 75 contractors that show up for that. Most of you are general contractors, so I invite you to come to that as well too. That's through the North Carolina Building Inspector Association. That'll be coming up in June, so put that on your calendar. Also, before we get started, want to thank Christopher Cook with Alliance Insurance. They will be paying for, they took care of the lunch today. So we thank you, Chris and Alliance. And please make sure you go ahead and thank him for what they're doing with. Today we're going to talk about your industry. And, you know, we're kind of limiting our talks to 15, 20 minutes. Our lunch is going to be around 11:45, 12. Probably more like 12 because I'm going to be running longer than what's on the agenda, but I got a lot to say. Again, after lunch, we're going to have a question and answer. So anything we don't answer here, you're going to have that opportunity. Department of Insurance is here. General Contractors Board is here. You got ears, so use them. You got questions or concerns that are not being met during this presentation, this is your time, okay? We got an inspections department from Forsyth, Stokes, Yadkin, Wilkes, and Davie, along here in Surrey County. So we got inspections department here. We're going to try to get some consistency here because that's one of your concerns. Other counties are not seeing the same thing. So we're going to try to do that. We're going to start it here and see what happens, okay? Lunch, I think we're going to go about 45 minutes. And I think it's, if we need to go longer, that's fine. But I'd like to, with what we got to cover, I want to try to do it as quick as we can. Again, the presentations today are not the Bible, okay? It's not what we're here to brainstorm. Your industry is not in our code book, so it's hard for inspections departments throughout the state to inspect your industry. So here's an opportunity for us to come together, brainstorm, get some guidelines together, on how we can build some consistency through the state. And if we can start it here and in the state, we can take it to the nation because we are the capital. Surrey County is the capital of the metal structures. And why can't we be the ones to start the regulations? Or not regulations, but the rules or guidelines to follow throughout, not only here, state, but into the nation. So I think this is a very big day. And I'll be honest with you, it's a long time coming. And I'm so thankful that many people have showed up for this. The Department of Insurance is here. We got Pat Geit. He's going to be up here. He's Chief Code Consultant. Dan Dittman, he's a Chief Energy Code Consultant. Tara Bothlemus, she is the Chief Accessibility Code Consultant. My good friend Curtis Huff, he is a North Carolina Building General Contractors License Board investigator for Northwest. He's all you general contractors, I highly recommend you get up and talk with him. Even though he's an investigator, he is your biggest ally. He is your biggest ally. You may get up with him, talk with him, all right? So make that. And also, before you leave today, talk with these people from DOI. We're all here to help you in your industry. It takes communication. It takes us talking together and working together. They're here today for you, so take advantage of that. We got Mark Berrien, Surrey County Commissioner, Melissa Hyatt, soon to be Commissioner. You've got zoning departments from the townships of Elkin, Dobson, Mount Airy, and Pilot Mountain here. You've got Again, the inspections department, we got architects here. Tony Chilton, we've got Yancey Powers here. So we've got people here for you. These are your people, this is your team. And that's how we look at construction projects, as a team. And when we're all working together, your projects will go a whole lot smoother. Little background on me. I've been in construction I was a commercial construction for 22 years. 15 of those as a commercial superintendent. I worked as a building inspector in Winston-Salem for about 5 years before I come up here. I've been up here about 4 years. I'm on the North Carolina Building Inspectors Association, been there for about 5, 6 years. I'm the Area 2 Director. So I have a lot of construction background. I understand where you guys are coming from. I've been out in the field. So I understand it. I want to work with you guys. And again, it goes back to communication. Everybody asks, what is code? Building code is a D-. Okay? It's the lowest you can get without failing. That's what the building code is. Do you want a D- home? Do you want a D- structure? No, you want something better. So you want to build better. You want an A+ home, right? You don't want a D-. So yeah, the code we're going to talk about today is the bare minimum you can get away with. But think about what you're giving your customers. Your reputation as a contractor and what you're giving, you want to give them better than what the code is. Get into some of the concerns that I have and what we see here in Surrey County. In our residential code, we have span charts. It tells us how far we can span that lumber before it starts having structural failure, okay? When COVID hit, lumber, you couldn't get a hold of lumber. So we had to start shipping things in from Europe, okay? Lumber from Europe. And the problem with that was their lumber was not the same as ours, okay? So the Department of Insurance had to send a letter out saying, hey, this is inferior wood compared to what we have, so you have to look at it this way. So why I bring that up? One of your concerns that you brought to me, because I met with a lot of companies before this meeting started, because I want to hear your concerns, because what I did was take your concerns and my concerns, I sent them to PAC and the Department of Insurance and to the General Contractors Board, so they can get their presentations properly prepared for you. So we can answer your questions and mine that we all have, and other inspections department. But the reason why I brought that up, one of them was you guys are telling me that companies are using inferior gauge metal. Not the same. Well, as an inspector, I don't know that. So how do we fix that? Because when I go out there and inspect it, I can see a tube. And you've even told me yourselves that you can't see it by your eyes. It's got to be a letter. So with this being said, how do we fix that? Do we tell the manufacturers of the tubing to put a label on there for us? It may cost a little extra money, but it's going to protect your product. It's going to protect you from the smaller companies and not putting the smaller companies down, but we need to educate them too that they need to use the proper stuff. And that would probably save that. That's an idea. Just like the PVC pipe, plumbing pipe, it's got that purple writing on it. It tells you when it was made, what it's for, and what the schedule is, and what grade it is. Maybe that's what we need to do with the tubing. That's one of your concerns that you brought up to me. Another concern is a permitting process. And this is a little stickler for us inspectors, because what happens is we find a homeowner that's got a building put up, he doesn't have permits. Guess what's going to happen? We're going to make him get an engineer to sign that off. That's $2,000 or $3,000 that they're going to come out of their own pocket. That they've already budgeted for this building to be this, but they don't have $2,000 or $3,000 to pay for that. That's hard on that homeowner or whoever that's been built for, and the company's long gone, done to another building. So here in Surrey County, I'll go ahead and tell you, we have software that's being used, and it scans the county. So you can tell your homeowners or whoever you're selling the bills to that we're scanning the county. And if you've got a structure that's on your property, it wasn't there 12 months ago, it's going to be flagged and sent to several different departments. And then we're going to have to do something. So let your people know, even though they try to refuse to get a permit, they need to get a permit, because we will find them. And at that point, it's going to be out of our, it's going to be very, very costly. It's cheaper to come to us from the front end than on the back end. So remind your customers of that. But, and I think you have dealers too that sell, but make sure they do that, because I have contracts that have been given to me by homeowners where the company has checked no permits required. And when they proved to me that they were not told, it's very hard for me to make them pay that $2,000 or $3,000. Somebody needs to be liable for that. It should be that homeowner that wasn't told properly. So that's another question that we need to talk about today. How do we deal with that? Another problem that happened about 3 weeks ago, talking about these smaller companies. We had two companies pretty much the same day, two different ones we've never heard of before. The homeowner came in with drawings, or didn't have drawings at first, had sketches. So we asked for drawings. Well, still didn't get what we wanted. Finally, we got drawings, but it was from a company that's no longer in existence. And they were 4 years old. That's a problem, because someone is stealing plans. And what we did was, we notified the company, well, we couldn't notify the company, but what we do, if we get them plans, we're gonna notify the company that they're being used, and let them know. Then I'm gonna turn it over to the engineer that really did that design. And what happened was, we turned that over, that engineer's got his lawyer going after these companies. That's how we're gonna try to do this, but that's communication. That's us working together and doing what we can to educate these smaller companies. And if we can't, we'll just have to deal with them as we can. Again, I want y'all to understand, we're all here together to work together. I look at the construction project like a triangle, okay? It's the strongest shape in the geometry, okay? Over here, you got your engineers and designers and architects. On this realm, you got your contractors. We're on the bottom as inspectors. If we're all three working together, tied together, your project's gonna go smoother, faster, and better, and you're gonna give your customer the best product they got. So, we thank you for working with us, and we thank you for being here. Let's see, lost my note there. Again, inspections department, sometimes we get a bad name. We're out here to help you. We're help in any way, shape, or form. So please contact us. Let us know if there's problems, there's issues. That's the reason why one of these other inspections departments are here too. So you can talk to them, get to know them. You have a point of contact when you go to that county or wherever else. So please introduce yourselves. They're here, and make that worthy. Every 3 months, I meet with the Surrey County Home Builders Association, okay? I sit with them, I talk to them about code changes, we talk about projects going on, things that we're seeing that goes wrong, or issues that we're seeing. Reason why I bring that up, maybe that's what you guys need to have here in Surrey County. Surrey County Metal Structures Association. I'll be more than happy to help in any way I can. I can't run it, but if you guys are willing to come together and make that happen, I think you can start something really big here. You can lead by that association. And I know you all's got different ways of doing things, and that's fine. There's not a problem with that. If we were all the same, it'd be pretty boring. But there's no problem being different. And the reason why I bring that up is I know I read a book a while back about the founding fathers. You know, they served this country, but they all had different religions. That's why you have your freedom of religions. And each colony, the 13 colonies, had a different religion. But when they were trying to come together, it was a war because nobody wanted to give up their religion. And it almost did not happen because a lot of the states did not want to be told what to do. And that's why the founding fathers realized, okay, we got our differences, but we're going to make this happen. We got to compromise. We got to come together and work. And that's what I'm encouraging you guys. Even though you guys are different, if you want your industry to be better, y'all got to have to compromise and work together and make it the best it can be. So put that into consideration of the association. As I wrap up, the last thing I want to mention is Surrey On The Go is taping this. So please, if you want a copy, please sign the roster. And there's a website. Put your email address on there. That way we make sure you get it. And that way there'll be a lot of information floating around today, but you can have it on file for your records in the future. So again, thank you for everybody being here. I'm gonna turn this over to Pat and DOI and see what we can do to make this better. Thank y'all.
My name is Pat Yip. I'm from NCDOI, Office of State Fire Marshal, Chief Building Code Consultant. Today I have another code consultant come with us to attend this meeting. I have Dan Dickman, who is our energy code consultant, and Curtis. He is our new residential code consultant, and also I got Tara come with us. She can address all the accessibility questions too. So today here we are trying to address the code questions, if you have any. We try to provide the interpretation of the code. Again, DOI or Office of State Fire Marshal do not make the code. We're not writing the code. We are doing as best as we can to provide the code interpretation for you guys. Let's go through some of the terms that we come across regarding this meeting. We have some concern from the homeowner, and when they have some code questions, they send an email to us. And today we are trying to address these questions to you guys and showing you what's the answer we provided, and hopefully it can create a more consistency in the industry. So some of the terms that we come across, like the first one here, pre-engineered metal building. So this is the one that we dealing with a lot with these metal buildings. So these buildings are defined as a set of fabricated component assembly that form a partial building shell designed by the manufacturer. So these buildings come in like a package. So they were like fabricated off-site and then delivered to the project site. Of course, they are metal buildings, so they are made with metal, non-combustible material, that's what we call. And a lot of times they were enclosed by metal panels on their walls and as well as their roof framing too. So the other type of building that we come across is a pole barn. It is using a large pole or post buried in the ground for a foundation and provide all the vertical support for the building. So these buildings were set up like using a post and embedded down to the concrete foundation and install all the horizontal girt members to receive all the panels and wall assembly too. So this is the two common construction method that we come across with the metal buildings. Another terms we come across, what is a condominium? This is not a term that we define in our building codes or residential code. So when I research online, this is the terms that combine barn and condominiums. So they're using a concept of barn building, the outlook of barn structures, and put the living quarters inside the barn to make it a condominium. Again, condominium is not a term defined in the residential code or building code. So how do we deal with that? It's a new structure, right? So also we come across a lot of these metal buildings and how they frame these metal buildings. So you can see that the backbone of the building is made up of a metal building, metal structures. And the walls and all the assembly inside the barn or the building is made up of, for example, in this couple of examples here, we're using wood studs, just like a typical house building in anywhere in the States. So the question we come across, a lot of question is, does this metal building, what code supposed to use for building this metal building? A lot of misunderstanding is, oh yeah, this is a metal building, it's not covered in the residential code, it's not covered in, it has to be built under the building code. So today we try to clarify that. So in our state, we have adopted residential code and building code. First, we look at the scope of the North Carolina residential code. The provision of the International Residential Code for 1 and 2 family dwellings shall apply to construction, alternation, movement, enlargement, replacement, repair, equipment use, and occupancy location, removal, and demolition of one or more detached 1 and 2 family dwellings and townhouses located on a parcel not more than 3 stories. Let's start it here. So the key here is the residential code scope is towards the one or more detached 1 and 2 family dwellings and townhouse located on a parcel. So if you're building a structure that can qualify as a dwelling unit, 1 and 2 family dwelling unit, townhouses on a parcel, you can use the residential code as long as it is no more than 3-story height above the grade plane with a separate means of egress, and their accessory structures is no more than 3-story height above the grade plane. So these are the criteria if you can use the residential code. It's not controlled or judged by what type of material you use. You can use masonry structures, you can use metal structures, anything you can think of for your residential house, as long as you meet the scope of the residential code. So what is a dwelling? So the way we have defining a dwelling and dwelling unit is under Chapter 2 in our residential code. Dwelling is any building that contains 1 or 2 dwelling unit used, intended or designed to build, used, rent, leased, and let or hired out to be occupied, or that are occupied for living purposes. The dwelling unit is a single unit providing complete independent living facilities for 1 or more persons, including permanent provision for living, sleeping, eating, cooking, and sanitation. So this is the key here. So in order to call it a 1 and 2 family dwellings or dwelling unit, it has to contain the living facilities. It has to contain the living, eating, which implies a kitchen. You have to have a kitchen inside, and cooking, and sanitation, which means you have to have a bathroom. So in order to call it a dwelling unit, you have to have the living, kitchen, and the bathroom inside. So in summary, for answer that question, which code should we use for the metal building construction? We want to start with the residential code. So if you meet the criteria, the scope of the residential code, which is a detached 1 and 2 family dwelling unit, if it is a townhouse, no more than 3-story height, and with a separate means of egress, and accessory structures to that residential structures no more than 3-story height, you can use the residential code. Now, when you have a building that does not meet the scope of the residential code, then you have to use the building code, which all we usually call the commercial code. Now, one question come up a lot is, what if we build like a structures that is not meeting this residential code? Like for example, if I build a storage building that is not tied to a residential house. The way we interpret that is this has to be under the building code because it doesn't meet the dwelling unit criteria. It doesn't meet the scope of the residential code. So we have to use the building code to interpret that. So another question we have a lot is, does engineer design always require for a metal building? So again, we're starting from the residential code first too, is when a building otherwise conventional construction contains structural elements exceeding the limit of section R301 or otherwise not conforming to this code, these elements shall be designed in accordance with accepted engineering practice. So the other part of that is tell you how to use the engineer for that. So the key here is that if your project, if your structures contain structural elements that exceeding the limit of section R301, R301 from the residential code set the criteria, the design criteria for your building. So it set up what's your windows requirements, what type of references you can use for your building, or the second criteria, not conforming to this code, which is a residential code. So the rule of thumb is if you have a building that does not conform to the residential code, again, we look at the residential code as a prescriptive code. So it gives you the design of the structures. Like for example, chapter 5 gives you the floor, chapter 6 gives you the stud height, brace wall, chapter 8 gives you the rafter size. All these was covered in the residential code, right? If you can use this information, these design elements for your building, you don't need an engineer. You can use the residential code for that. Now, if you have something that is not covered in the residential code, then under this section here, it will require to have an engineer to help us to evaluate whether it meets the code requirements or not. So another thought is the building permit. Now this, we want to cover that. This one first is, which code require the building permit? So building permit is actually not coming from any code, not coming from the building code, not coming from the residential code. It's actually coming from the general statute, 160D-1110. Except as provided in subsection C of this section, no person shall commence or proceed with any of the following without first securing all permits required for the state building code and any other state or local laws applicable to any of the following activities: the construction, reconstruction, alternation, repair, movement to another site, removal or demolition of any building or structure. So you should have permit for any construction. Now, unless it is exempted by the North Carolina General Statute or the NC Building Code or the Residential Code. So the General Statute actually have an exception for farm buildings. So if your building qualifies as a farm building, not used as sleeping purposes, then under 143-138 before it exempt from the building codes. Which means that if you qualify that statute requirement, this is a farm building, meaning non-residential, non-residential buildings or structure that is used for bona fide farm purposes as defined in these general statutes here. That is an exception from the general statute, that you don't need to meet building codes. Now, building code also have exceptions. Section 101.2, the scoop exception number 2, saying pretty much the same, except that if it qualifies as a farm building, not used for sleeping purposes, or not used for storage of any hazard materials in exceeding the table 307.1 or 0.2 or 1.2, then you are exempted too. From the residential code, we also have one exception for similar structures, which is identified as an accessory structures. Under item 6, detached garage, detached carport. So under accessory structures, detached carport is supposed to be, you have to construct per residential code. But there is exceptions that is applied to that. Portable lightweight carport, not exceeding 400 square feet or 12 feet mean roof height, is exempted from the residential code. So if you have an accessory structures, now again, That's why I put the definitions here. It has to be a accessory structures to the dwelling unit. It cannot be a standalone structures, because a standalone structure will be under the building code. If it is an accessory structure to the residential building, and if you qualify as not exceeding 400 square feet and not over 12 feet of a minimum height, and use it as a carport, you're exempt from the building from the residential code too. So these are some of the examples here. So if you have a carport less than 400 square feet and less than 12 feet minimum height, these structures are exempt from the residential code too. Again, that has to be tied to the accessory to the residential structures. So one thing that I want to clarify is, even though you are exempt from the building code, either permitted by the general statutes, building code, or residential code, all electrical system works require permits too. And 143-142 require that electric wires of house and building shall conform with to the requirements of the building code and any other applicable state or local laws. So even though you qualify as a farm building, even though you have a carport that exempt from the building code or a residential code, you still have to have an electrical permit if you have any electrical system work involved in that. So let's talk about how do we comply with the code. So I want to clarify one thing about the documentations of applying this permit. So I want to clarify what is a floor plan and what is a structural building plan. So a floor plan basically is a visual representation of the home interior, while the structural plan is a detailed document that details the support, load-bearing elements of the building. So when you see a floor plan, you see how the designer divide the interior space in the house. But the structural plans, it covers all the backbone of the house. For example, the foundation, the framing, the roof framing, any details for that. Again, this is one of the examples of the floor plans. The floor plan will show the interior wall location, the room's layout and size, or the size and location of the windows and doors. The reason why we have to have a floor plan is to make sure that this building complies with the code. There's a lot of requirement from, for example, from chapter 3 in the residential code. Talks about the rooms lanes. So if it is a bedroom, what do we require? A bedroom requires egress. The special egress requirement for a bedroom. We have to have a egress window applied to any bedroom. The room size. So we have a room size and minimum dimension to a habitable area from chapter 3 in the residential code. So these floor plan will show all these for that particular building, whether it meets the code or not. Now, from a structural plan, typically a structural plan, like I said, it covers the foundation, which including like footing, foundation wall, piers, concrete slab, anchorage, detail, things like that. In the framing plan, it covers the girder size, the floor joist size, pin, any type of wall sheeting, the wall stud size, brace wall head size, beam or beam supports, roof framing, roof sheeting stuff, all these framing elements. Also, it usually covers the structural details too. So in a structural plan, it covers the construction, the structure requirements. But most of the time, structural plans not necessarily cover the floor plan's details. In a structural plan, you probably won't find out the room length, the dimension of the rooms. It doesn't cover the room's layout, the interior wall location. That doesn't cover that stuff, that type of information. So that's the difference between these two types of plans. So there's a lot of question about the structural plans too, when we receive the question from the homeowners or local jurisdiction. So one of the way that we look at the structural plan is from the code official standpoint, we don't review the details of the structural stuff. So we cannot evaluate whether you need 5 bolts here, 10 screws here, 5 nails there. We cannot do that because we're not PE. coefficient is not PE, so we cannot interpret the design of that. But we can use and we interpret the structural specification typically covered in the first page of the plan. It tells us what's the structure was designed, what's the boundary for this design for. One of the criteria we can review is the risk category. So sometimes we come across a structural plans that cover the risk category. Risk category is not covered in residential code, but it's covered in the building code. But this is one of the information that we can review. So risk category come with 4 different categories covered in the code. The first 1 or 2 will most likely apply to the meeting today. 3 and 4 is more important buildings, for example, airport, fire station, EMS station stuff. But I want to clarify that. Risk category 1 is a risk category 1 building that has the lowest hazard to life since they have little or low human occupant, or for those that are temporary, the exposure to hazard of earthquakes, floods, slow, or wind will be considerably less than that of permanent structures. An example, carports, barns, storage shelters. So these are shelters, these are building typically not for human occupancy. So for example, you have a storage building, a small storage building that, in a farm, or even though attached to a primary residential structures too. So these are risk category 1. Risk category 2 typically cover anything that's not defined in 1, 3, and 4, and it covers most of the residential buildings. The reason I want to bring up that risk category, different risk category, is we come across some plans that in the plan, the engineer will put designate that building is designed for risk category 1. Now, if it is designed for risk category 1, it cannot be used as a residential purposes, because the risk category, it has to be a risk category 2 in order to use that building for residential use. So this is that's one information that we come across that we need to clarify. Another thing is the load requirements. So chapter 3 in residential code had outlined some of the load requirement, especially for live load, for residential structures. And also 301.21 table required in North Carolina, all the roof loads for residential structures has to meet 20 PSF live load. And also, of course, there's other criteria you have to meet to meet the local and geographic design criteria. So the reason I want to bring up that loading requirement is we have some question from the homeowner about they receive a plan that the structural loadings on the plan might not necessarily meet the criteria outlined here in chapter 3 in the residential code. And this is the minimum that the code official will look at and review and make sure that the loadings in the structural specification on your plan meets the residential code requirements. Another loading that we have concern is the wind design criteria. So North Carolina actually have different wind design zones in the state. So we have a coastal state, we have a higher wind zone. The middle state, we have a typical wind speed on that. And then to the mountain, we actually have a higher wind zone because of elevation change. And this wind speed design criteria is also covered in our residential code, tables 301.4, maybe? Yeah, 30124, 30125. And this is set as different counties. So it tells you where you're located, which county, what wind speed you're supposed to design for that structure. So there is one tool that provided by ASC, American Society of Civil Engineers. The hazard tools, I have a link here and a QR code. You can take a picture of that too. This tool is pretty handy. And what you need to do is get an address for your building design. and plug into these tools, basically it will give you the design criteria for your building. So for example, I put in, I don't think you can see that, but I put in 915 East Acton Street here, and then ASC 710, which is the addition of ASC that we are still in effective. And this is a risk category 2 building, and the soil, which is the default soil class. And the outcome here is that's the summary report that you can get from that tools. Was the wind speed 115 meets our chapter 3 requirements, and all the seismic parameter which is required for the building code summary. And also, slow too. But some of the slow you might need to contact the local, because some of the area in our state might have a higher slow requirement. So in summary, there is some of the interpretation we have provided from our department. We have contacted the North Carolina Board of Engineer and Survey and got their interpretation about some of these steel metal building structural plans. So the interpretation from them is these plans, we will call them a engineered shop drawings. So they have, they cover different dimensions of the design, but they're not necessarily site specific for any project. There is no site address for including in those packages. And then from the engineer board, they will interpret that as a shop drawing. The building has been, and also there is a problem that, or concern from the homeowner that they received the plan, but again, when we review the structural specification, these structural specification doesn't meet or exceeding the local criteria. For example, somebody might purchase a plan, and that plan was built in Wilmington, which is a high wind region, and that required in New Hanover County, which is 150 miles per hour wind zone. But if the structural specification, the wind speed cover in that plan is only cover up to, let's say, 140 miles per hour, that plan cannot be built in that region. In other words, that plan will have to be re-engineered again to make sure that all the elements, for example, connection, framing members, all that stuff meets the local climate criteria. Now also, we come across these silk shop drawings come with different options for different size of the building. The owner can act as their own house designer, providing they meet some of the criteria from General Contracting Board or the permit requirements. But they have to select their own options. The co-official cannot do that for them. So if they present a plan with all these options, the homeowner has to pick their options, meets the criteria for their local climate area or the size of the building. The co-official cannot do that because otherwise it will put them into a designer position. So this is my contact. Here, and the QR code will give you the link to our office. We'll give you the contact for different consultant. I'm going to pass it to Dan Dickman. He's going to cover some of the Chapter 7, which is the weather protection requirement from our residential code. So, all right.
My name is Dan Dittman. I'm the Chief Energy Code Consultant. We all know the Energy Code causes, dental caries and acne in teenagers, so it's all the world's problems. But other than that, why am I talking about the weather-resistant barrier? Because people think it's in the Energy Code. It's not. And we spend a lot of time talking about, no, it's, well, spray foam, it's a vapor retarder, it's an air barrier. How come you're talking about the weather-resistant barrier? Because it meets the Energy Code. What I'm going to talk about is not in the Energy Code. Before I get going, are there any spray foam installers in here? No? Any spray foam manufacturers? I know there's some in Surrey County. Okay. Any metal panel building manufacturers? Okay, we got those. Okay. And this presentation wasn't necessarily put together for this meeting. It wasn't. And by the way, we didn't get a chance to get together and coordinate all our meetings. We just said, Dan, you need to be there on Monday, so the time back here. Happy Patriots Day, everyone. I missed the Boston Marathon this morning. That's a joke. I'm not. I'm not a marathoner, but fast guys, they've been long done now for a couple hours. Let's just jump right into it. The water-resistant barrier omission and the code implications on that. Because these were compiled with projects that came up where they didn't use it and they tried to back engineer into it. And we want to understand why you would wire it, et cetera. Like I say, this is not a how-to manual or a formal interpretation on spray foam, barndominiums, or approval of alternate methods. It's merely a guide to illustrate the code sections, the code officials, et cetera, dealing with external environmental forces, and the code sections dealing with the internal environmental forces. Like I say, it's intended to illustrate the code sections that are being cited. The issue is the exterior of the building, not the vapor retarder of section R702.7 or the air barrier requirements of the energy code. The issue is the water resistant barrier of R703.2, which is used in most residential applications. Remember, Pat hit hard on the prescription sections. That's what we're talking about. This, if you're in the prescriptive code, it's expecting to see this. So if you don't have it, what are you going to replace it with? Most of the common residential sidings are what we call ventilated sidings, such as vinyl and face brick are ventilated claddings. They're claddings. Metal building manufacturer, that metal panel, it has all the seams, that's a ventilated cladding. Little water can get in there, but a little air can get in there and ventilate it, clean it up, dry it up. That's a ventilated cladding. When you spray foam it, now it can become different. So, as I say, those ventilated claddings, they allow miscellaneous moisture either to drain away or evaporate back to the outside before it causes rot to the wood or corrosion to the siding or fasteners holding the siding. Roofing also requires water-resistant barriers or underlayments, but less exceptions and more reliance on manufacturer's instructions what to do if you don't have a predefined alternatives. There's also a considerable challenge an existing building has versus a new building. We get this quite often. Someone wants to repurpose a machine shed because the removal of any existing roof may cause substantial damage to it in order to install any underlayments. So it never rotted before. We get that before. They have a machine shed out there, it's been there for 40 years, and they say, well, why can't I spray foam it? Well, machine sheds many times don't have any interior coverings. You look up, you see the steel. They may be unconditioned. Therefore, the inside is not much different from the outside. You don't have a vapor drive. Miscellaneous moisture that gets in the seams can drain away inside the building and evaporate in most conditions. When these buildings are repurposed for dwelling units, these seams and the weather forces acting on the cladding are still present, but internal finishes and insulation may make it difficult to see, and the addition of air conditioning now on the inside increases the amount of time that you're going to have condensation. So the addition of air conditioning provides a driving force that greatly extends the times during the year where condensation occurred under the building claddings due to a larger temperature and humidity difference between the interior and the exterior. So it's not all just words. I have some pictures here. Here's your generic outline of your house. You know, the rain pushes it off. The sun has remarkable properties of driving moisture back into the environment. See? So we're going to zoom in on some of these items. So exterior coverings or claddings are the roof system and the wall system. We're going to zoom in on some of these. R703.11, water resistance. This is from the residential. Requires a water resistant barrier behind the exterior veneer, that's our claddings, required by R703. The purpose of claddings: they shed water, protect the remainder of the wall and roof system. Vinyl, face brick, and wood clapboard are all ventilated sidings, as are many of today's sidings, so they rely on a drainage plane behind the siding to allow the miscellaneous water to either drain away or evaporate back to the outside before it causes rot to the wood or corrosion to the siding or fasteners. Likewise, metal panels also have seams and penetrations and cutouts for windows, doors, and utilities. Any water, whether from weather or from condensation, people always forget the condensation thing. And, it's a driving force that's always there. They must be planned for and either provided a drainage plane or a means of re-evaporating so it does not sit and cause rot or rust to the cladding fasteners or deterioration of the cladding itself or the substrate. Remember the wind zones that Pat talked about? Well, that cladding only stays on there as long as your fasteners are not corroded away. These sidings are water resistant, not waterproof. And they have a daily response with the sun, the water vapor in the air, and the building properties they are made up of and help protect. So here again, we have a little illustration there. And we're zooming in on the cladding, this clapboard type cladding. So, zoom in on it again a little closer. The raindrops highlighted in red are drops that made it past the exterior cladding. They are drained by the water-resistant barrier. Notice how it kicks out on the bottom there? That could be your flashing, kick-out flashing. Okay? This is a normal everyday house. The barrier could be builder's felt, house wrap, or other materials designed and installed to be a drainage plane behind a cladding. Even in normal construction, spray foam does not address the drainage plane of the exterior cladding as it was applied from the interior and is typically under the sheathing. So let's change the design outline for a pole barn or barnuminium. Okay, here you have a pole barn. I know there's some variations, but here's a basic pole barn outline. We'll zoom in. Now, take the case where you have a basic machine shed type pole barn, good strong construction, but there's no insulation and no sheathing. Stray water that, the little red drops there, that gets past the cladding can drip down the interior of the metal panels or drip down into space, but does not puddle up against frames or fasteners. No harm, no foul. Now let's put internal walls in there, and let's put some spray foam in there. Now, there's many different ways the walls and roofs could be done, I understand that, both with and without continuous sheathing, but in all cases, the concern for what I'm talking about here is the concern for water that gets past the cladding. How is it drained? How is it handled? That's what the prescriptive code is asking for. So here's a cross-section of a wall in between the vertical posts. These are your wooden girts, and the exterior there, that's pointing to the metal panel on the exterior. And your interior finish, which would be kind of like basically usually a gypsum. Here's an exploded view of it. So the rain is hitting the metal panel on the outside. But suppose you had a standard construction, you have a water-resistant barrier such as Tyvek or felt, that would be your drainage plane. Anything get past there, drains down in. So a little water usually doesn't hurt. The code just does not want water to come in and sit and not be drained or re-evaporated to the exterior. The code does not want the water to soak into the wood members and get to a point where they rot or corrode the fasteners. Here is a different view, just face on. Now the horizontal seams may or may not be present. It depends on the style of the cladding. But again, you want to avoid water drain down and pooling under the metal panels anywhere, and especially between the wood and metal panels at the fasteners. Roofs in particular have no specific exception for the water-resistant barrier or underlayment. It's a more brutal environment, it can be. So here's the traditional method of a roof. And now let's, you have a metal panel, that's your cladding, and then you have a water-resistant barrier, that could be a builder's felt or its equivalent, but then you have an underlayment, OSB, that would be normal. And then your purlins, and then your interior finish could be gypsum and your fasteners. Here's an exploded view of that. But the key here is that underlayment, the OSB. Now here's what we're getting into, what I start getting into a non-traditional method for the residential prescriptive code. We don't have a water-resistant barrier. We get this question. They just want to spray foam directly to the underneath of the metal. Simplest way, I understand that.
But the builder's felt is not equivalent, not present. And the underlayment, the OSB, is not present. The metal panel is actually providing the structure. You know, like a screwed on metal roof per se, it's the structure also. And of course your purlins. So let's explode that. So zoom in on that a little bit more. So, nope. Zoom in again, sorry. But you see there, you know, see those little red raindrops? It's like, okay, those are the issue. Right there. This non-traditional method, how does it handle that? You know, what happens here without a drainage plan? Does the water re-evaporate to the exterior without damage? Or does the wood soak up the water and start losing its ability to withstand pullout? Or do the fasteners or metal panels start corroding, thereby reducing the cladding adherence properties? Now, here we understand there's a couple different ways to do metal roof or metal cladding tie down. The basic one shown in there first is the metal panel fastened at the ridge, through the ridge. This would be like a metal panel that it's fastened in the valley. And you could also have a metal panel standing seam with clips. So I just point out there's many different ways you can fasten metal cladding to a roof, but the water resistant barrier is not exempt by any given method, prescriptively. Okay. Here is an example of an existing facility that they wanted to repurpose, and I helped illustrate it. This is the pictures from the outside, and then the picture on my far left there is the picture from the inside. An existing machine shed. It's a screwed-on metal roof. There's a close-up of the seams, and there's the underneath from the inside. So let's zoom in both the interior and, the exterior and the interior, what those seams would look like and how they're crossing those wooden members. So your bulk water, it just drains away. You know, we see that, no problem. However, warm, moist air migrates in. So draws it in the evening. The metal cools off rapidly. How many of you ever seen metal roofs wrap or rain from the underneath if there's no insulation? Everyone see that? Do you understand that? That can be a daily process for many months of the year. But it also causes vapor to condense in the seams and the pocket form between the metal and the wood framing. Now, condensation in the seam itself will just drain out. It's condensation in the pocket that is an issue, as it cannot drain out. So the sun hits it in the morning, daytime. The sun is going to drive out some of the moisture during the daytime, but it's unknown if all of it will be driven out or if seasonal drying will overcome seasonal wetting. Again, the prescriptive code simply avoids having to answer this question because the drainage plane will be uninterrupted. Remember, it just says you're going to have a drainage plane, period. So we as code officials and the code officials in the field, they can't answer this question. I can't necessarily answer that question. The prescriptive code that's been built over decades of empirical, it even avoids having to answer that question. But if you're doing an alternate method, you need to know the answer to that. But this is, like I was saying, we're pointing out that here's the code section that people miss when they talk about spray foam water. So, like I say, in evaluating any alternate method, this needs to be considered since the design has been changed from the prescriptive code assumptions in the code. So, imagine you just have water, present insulation. Any air that is drawn in can migrate into the space. And if the moisture condenses, it can either drain away or re-evaporate without causing any significant rotting of wood members. You've seen buildings out that have been there for decades, right? And they're fine. But now we spray foam those, and now you've changed it. So okay, you come in, and per R806.5, unvented attic and unvented enclosed rafter assembly requirements, you come in here, you spray foam this, wow, that looks good, you know? We know we're not gonna have any more moist air coming from the interior touching that metal roof, so we're good, right? We get that call all the time. Spray foam's a, you know, air barrier, it's an air barrier, it's an air barrier. I understand that. It's not an energy code issue, it's in the residential code. However, this application does not stop the migration of warm, moist air from the exterior from migrating into the seams and interacting with the areas above the wood members, but below the metal panel, AKA R905.1.1, the underlay. So, even though the spray foam, I understand it adheres tight to the backside of that roof, but is it getting everywhere? Or are you having, is there little pockets in there? Can anyone guarantee those pockets aren't there? So, and this is, see where the wooden slats from below, they're superimposed on the top for illustrative purposes. What's happening across all those seams where the bolt, every bolt goes in, and where this seam, the vertical or horizontal seams are occurring. Each point where the metal panel seam or fastener penetration is up against the wood panel, kind of a small pocket that no longer has a drain. Now, I want to read the second bubble there. The wood in these areas need to be periodically inspected to make sure they are not holding excessive moisture and therefore reducing pull-up forces. That's from a Huntsman's building product. That's one of the Icynene, they own Icynene and SESC foam, I think. Big manufacturer, quality manufacturer. That's their suggestion in their literature, sales literature. So I'm not making this up. Here's, again, the basic house underlinement. Right there. That's just a different view of pointing it out. You know, what's happening there? They're concerned. They realize there's a concern there that's not addressed in the prescriptive code. So what do you? Again, here's the traditional method on my right. With spray foam. And if you say people want a simple way to do this without having to avoid all these issues, you can still build it with sheathing. And a lot of those issues go away. And like I say, there's many different ways to build this. This is still an easy way that, okay, you avoid all those issues that we just talked about if you just sheath the building. So, getting into some summaries here. If the prescriptive code is not being followed, how does the proposed wall and or roof construction sequence and materials provide the equivalent level of protection to the building assembly? And is the permit holder addressing all the required code sections and functions of the roof or wall? So if the prescriptive code is not being followed, 904.1, the requirements set forth in this section shall apply to the application of roof covering material specified herein. Roof assembly shall be applied in accordance with this chapter and the manufacturer's installation instructions. Installation of roof assembly shall comply with the applicable provisions of R905. 904.2, compatibility of materials. Roof assemblies shall be in materials that are compatible with each other and with the building or structure to which materials are applied. So I think of an example here. Pack, can I have all the contents of your wallet, including PIN numbers? Say no. Pack, can I have all the contents of Tara's purse, including her PIN numbers? Say you don't care. I don't care. Tara, you have to give me all your information. Say no. No. But Pat said it's okay. It's not his call, is it? So when the spray foam manufacturers, and bless their hearts, they're great people, don't get me wrong, say, oh yeah, you can spray it to all the under panels, you know, that's good. Well, you didn't ask the metal panel manufacturers there, or the metal building companies. That's what this code section is saying, 904.2, compatibility materials. Roof assembly shall be of materials that are compatible with each other and with the building or structure to which the materials are applied. There's two parties there. Everyone see that? So you can't just ask, you know, Pat, if I get her money, you gotta ask both people, right? So just to draw this together, yeah. And the blue bubble, it's not enough to demonstrate compliance with only R806.5. Other sections are also required. And R806.5 is the unvented attic and unvented enclosed rafter assemblies. That's That's controlling moisture drive from the inside. The last 15, 20 minutes, I was harping on controlling moisture drive from the outside, and that's what gets missed a lot in calls we've been getting in from the office. So, I guess I won't get into alternate methods here because, like I say, not the, we can talk about that after lunch. Oh, so at one point there, it can be difficult to redirect an installer's mindset from the energy code air barrier requirements and the vapor retarder requirements of section R702.7 to the residential building code requirements R703.1.1. And that was the purpose of this little issue here. That's the end of that.
I want to just follow up and say, you guys in the room who are designers and building inspectors and contractors alike, I think these two fellows right here just gave a great presentation in my opinion. I was a former building inspector from years back, and I think they did a great job to provide good scenarios and talk about when permits are required, design criteria and that sort of thing. So, again, my name is Curtis Huff. I work for the NC Licensing Board for General Contractors. My title is Field Investigator, but we are also field representatives, which means we like to keep our public informed, to talk to them about boards, rules, regulations, and that sort of stuff. My presentation will be as short as I can possibly make it. I think we're running a little bit behind, but I hope that this afternoon, as we have our Q&A, so to speak, that I can get a lot of good questions from you. And I'll be happy to answer anything I can. I brought cards so that you can contact me later if you need to. So from where we sit, we don't talk about the building code so much and what it takes and that sort of stuff, what inspections are all about. We're talking about the guys that actually put it up, who construct the building. So these are our laws and regulations that pertain to general contracting. And just a little bit about the board real quick so you have an idea what we're all about. A lot of guys in the room know, but some of you don't. We're the General Contracting Board. We've been around since 1924. We're going to be 100 years old next year. And we regulate the industry of general contracts when you have to have licensure with this state. And these, of course, these are our board members presently. You may or may not know some of these folks. They're all appointed by the governor. We have, I can't bring my notes up with me, but we have 3 public members, 2 residential building contractors, one building contractor, 1 building sewer, 1 highway. Those are the members that are appointed by the governor. They serve 5-year consecutive terms, 5-year terms, and they can be 10 years consecutive. So that's kind of where they come from. Here, this is the intro about who we are. And if you notice this section right here, this $40,000, remember that number. We're going to talk about it more here in a little bit. These are the classifications of licenses that we issue. If you get into this specialty, I think there's at least 14 more. And of course, unclassified means they can do. That's the licensee that can perform general contracting and anything that's above that. So let's get into the meat of everything. 87-1. This is a general statute, by the way. This is not a board rule or regulation. This is the law. And I will read the general statute to you line by line. I'll kind of give you the short version of layman's terms, what it means. And it kind of says this, that if any person, firm, or corporation who chooses to superintend and manage a project on behalf of someone else, for which the cost of the undertaking is in excess of $40,000, you must hold licensure with the board. And that's what the law says. Every project in this state, if it's over $40,000, if we're talking about a general contractor project, for which the cost of the undertaking is over $40,000. Now, an exclusion would be the land itself as one exclusion, but we're talking about even moving the earth to that site, to create the site. That's part of the undertaking. Okay, the footing, foundations, if there's going to be electrical, plumbing, heating, and air in the project, albeit the general contractor doesn't install that as part of his scope of work as the what? General. So that's the cost of the undertaking. $40,000 is the max number. It's like that for everybody. Okay, across the state. Now, the exemption is if you want to be your own contractor, your own person to do the work. So, if, a good example, myself, back in 2006, I don't hold a general contractor's license, nor do I hold plumbing, HVAC, or electrical, but in 2006, I wanted to build my own house, right? I own my land. I intended to be my own general contractor. So there's an exemption for that. I believe it's right down the way here. And it's not exemption for licensure. It's not the 87.1, but it's right here in this 1.1. It's not an 87.1 for exemption, but it's right here in this section right here, under number 2. And it says that if I own my land and I intend to supervise and manage every aspect of the project, then I am entitled to do my own work, okay? And that's a privilege, that's a good thing to have. You want to be able to do your own thing on your own property. You don't want the government to tell you what to do and what you need to be doing if you're able to do it yourself, right? So, as long as I superintend and manage every aspect of the project, I am able to be my own general contractor. Okay, I can do my own thing. I hire and pay everybody out there. Right, I hire and pay everybody, nobody else does. So that's what the exemption means. So, got a pretty good idea about general contractor. Now, I think there's going to be some good Q&As coming up this afternoon, probably, about, especially the metal building company folks, who's installing, who's building, who's erecting, who's contracting. I'll get into the weeds on that this afternoon if you like. For the sake of time right now, we're just going to talk about who we are, what we do. So, now, that being said, we regulate the practice of licensees. And we hold our guys accountable for all sorts of things, okay? If you have a license with this board, we hold you accountable for operating, you have to operate the name, style of the license. Your qualifier is a part of the license, whether it be a sole proprietorship towards a corporation, you have to be a W-2 employee, managing member, that sort of stuff. If you're a residential building contractor, you can't go out and build a 3-story high-rise. What's it called? 4 stories is high-rise? When we turn into high-rise. Nonetheless, you can't build anything that big. You got to be strictly to residential, right? Which is family dwellings, townhouses. I forget what the other one is. Nonetheless, so you have to stick to the classification. If you're a pool contractor with the board, you can't build a house. You kind of get the idea of how that works. And then we have limitations, dollar amounts on projects that you can work up to. We have limited, intermediate, and unlimited associated with that. So that's the biggest part of what we do. And if there's licensees in the room, you kind of have an idea of what this is all about. If you want to know more about licensure and what it's all about, you can see me after the presentation's over with, and I'll be happy to discuss it. Give you a card if you need it. You can contact me later. So now, we're going to move on down to another general statute. That's titled 8713. 8713 is a general statute that speaks to the unauthorized practice of general contracting, impersonator contractor, false certificate, giving false evidence to the board, and penalties. Now in 13, and not the one below it, where it says 13.1, board may seek injunctive relief. For the most part, this section states that if any person, firm, or corporation is engaging in the practice of general contracting for which you don't have a license, you're guilty of a misdemeanor. All right, a misdemeanor. We all know what that is. But who prosecutes misdemeanors? Not this board. That'd be up to the DA, right? It's because a misdemeanor is criminal, albeit a minor infraction, but that's prosecuted by the DA. Some of you are probably wondering, well, how often does that happen? I can tell you that I've been involved in the construction industry since 1992 when I went to work as a building code official. And I myself only know of one local government that indeed prosecuted an unlicensed general contractor, only one time. It may happen a lot, but we're just not in the business to know that. So it can't happen, I can tell you that. 8713.1. this talks about unauthorized practice. For an injunctive relief. All right, this involves the board. Okay, this general statute says if this licensing board suspects that this activity is going on, then the board may prefer charges through civil courts, superior courts, to seek an injunctive relief against you. In other words, in the end, while we regulate the industry of licensees and we can kind of hold a strong arm on them, strong hold on them, I should say, we can kind of stipulate how they should practice or what they should be doing in the practice. When it comes to unauthorized practice, guys, we don't really make a call in the end. But we do give it to a Wake County Superior Court judge. And I'll tell you this, we're in the business of putting guys out of business. That's exactly what we do with this. Of course, where we are involved, we typically see some pretty egregious situations where somebody who's probably a framing contractor on a residential project, he's been in the business, I don't know, for 4 or 5 years. He decides he's going to go out for his buddy and build him a room addition, and the cost may be around, I don't know, he may give him cost around $60,000, when realistically, it's going to be about a $70,000 or $80,000 project. You know, the unlicensed guy's not qualified enough. He thinks he knows. He's tried. But in the end, it just wasn't there with it all. So what happens then? You know, this guy's got his money. He's well over $40,000 been paid, but it's going to take a ton of money to go back and probably first tear out some stuff that's not right and rebuild it. So that's kind of the egregious part of all that. But from where we're sitting, all of that doesn't come into play. We're only looking to see whether or not he's practicing our license. That's all we can ever do with that. So in these cases, it says, of course, the board may seek an injunctive relief with the courts. And what that typically involves, I tell folks all the time, it's all about following the money. If I have gone out and Pop wants me to build him a building, a room addition or something like that, and I give him a contract for $50,000, whether I drove a nail or not, it makes no difference. I have offered to engage. So if it's known to the board, we, first of all, we're going to file a complaint against you for doing the work, or the unlicensed entity, me in this case, for doing the work, and we're going to ask for contracts. We're going to ask for all receipts, that sort of stuff that we paid to the unlicensed entity. We're going to group it all together. We're going to take our complaint back to our board, because every complaint filed in this state is heard by our board, every one. Albeit we have a process to get to that first, kind of weed out the complaints that are not worthy, so to speak. But in any event, our board would then decide, okay, I've got $65,000 worth of cost here, documented. We are going to proceed. Our decision is to proceed with an injunction. So we then will file with the courts. This is civil, by the way, right? Civil, not criminal. We'll file with the courts. We're asking the courts to hear our case, and we're asking the courts to enjoin the unlicensed entity. So in the end of all of this, we're going to have, it's going to be in the hands of the Wake County Superior Court judge. We can use any Superior Court in this state. We use Wake County. Why? Because our terms are in Wake County. We're in Wake County. But they'll head down, they'll file their complaint. Keep in mind now, it's been filed against me, so I'm the defendant in this case. I'll be summoned, so I'll come down and give them my side of the story, tell the judge what's going on. But in the end of all, if they find in favor of the board, the judge gives the opinion that the unlicensed entity was indeed practicing general contracting. And so the board is granted this injunction. That means that the unlicensed entity is hereby enjoined from the practice of general contracting until such time, if ever, he becomes licensed with the board, or they become licensed with the board. That's how that works. Gavel drops, injunctions, put out of business. That's it, we're done with it. Of course, there's fines he'll pay, there's costs for the investigation now, up to $5,000 that the judge will give back to the board. And that's how that works. So that's our process. Now, a further question may be, well, what if it gets caught again, right? If you get caught again, we go through the same process, and I think it's called if there's an attorney in the room, people who know a lot about legal, just cause, we have just cause hearing, and we go back before the court and we're showing the judge, hey, judge, he did it again. Here's another one. Judge looks at it and by this time he's going, you know what, man, you're ticking me off. 30 days in jail. He held in contempt, and it goes for every single crime you have done over 30 days. If you guys are from the Raleigh-Durham area, probably 4 years ago, you may have read about in our newsletter, we had an injunction case heard by the courts 3 years prior to enjoying the unlicensed, put him out there. Well, we caught him again, except we didn't catch him, so to speak. Troubleshooting call, Channel 11, right? Calls up our board and says, hey, we get this information, and we acknowledge a complaint with just cause hearing back before the judge. There were 5 different jobs going on. So he got 30 days in jail per offense. That's probably the most egregious we ever seen. But that's the process and how it goes on. So that's how that works for us. I'm trying to be brief, and we'll let you ask questions later on. That's kind of our process for the unlicensed folks and how that works. So I'll be around after lunch. Glad to help you guys out unless I can. Oh, one last thing. While I got you, this is our investigative territory. There's only 5. I think probably I've got, of course you see the green, we're in but some of you guys may be dealing with Wadis. If David County's in the room, Allegan, Ash, Watuga, might be Ryan Coke. So. But in any event, if you need any investigator, if you can't get me, you can talk to somebody else. I think they'll all give you the same story. So that's what I've got. Good job.
Well, good afternoon, everybody. It's never good to be the first speaker after lunch. So I'll try to keep you awake. As Keith said, my name is Wayne Moore. And I'm founder of Moore & Associates Engineering and Consulting. I am a senior civil structural engineer, emeritus, which is a fancy word for retired. And I'm here to talk to you about the right way and wrong way of carport analysis and design, fabrication of carport structures, and installation of those structures. And I'll try to hold it to 2 hours. I think that's what I have for now. In the beginning, the carport industry started out fairly humbly, providing 1 and 2 vehicle opening and closed carports, primarily for agricultural and residential use. I think we've all seen these on the side of the road. You know, what used to be $6.95, but I think with inflation it's probably $12.95 now. Typically risk category 1. You heard Pat refer to risk categories. I think also the building official referred to them. But these, again, primarily non-occupied risk category 1 structures, or just basically representing a low hazard human life, low hazard storage, low hazard storage structure. They typically were less than 30 feet wide, with eave heights typically 12 foot or less, and they were typically based on master design, which I'll talk more about shortly. Then came the larger carport buildings. These could be enclosed or open. They also, many times, were risk category 2, which means they were occupied in some manner, possibly as a workshop or a garage. They typically ranged up to 40 foot in width, with eave heights maybe up to 16 feet. These were typically site-specific engineering. Then came larger commercial carport buildings. Typically risk category 2, but there have been risk category 3 and 4 uses. Risk category 3 being a group assembly, large assembly building. Category 4 being a lifeline structure, housing maybe ambulances or emergency generators for a hospital. Typically enclosed in configuration, ranging up to typically 60 feet in width, but they have been wider than that. Typically with eave heights up to about 20 feet, and certainly site-specific engineered. And what has become a fairly recent phenomenon is their use as residential structures. Trade name barn dominiums. And these, of course, risk category 2 structures, as already has been talked about by state officials. Certainly, you have to address egress from sleeping areas versus through personnel doors on commercial structures. They have to be properly moisture controlled and properly insulated. There's been some discussion about that already. They typically range from 30 to 40 feet in width. Typical eave heights for single story, 12 foot, but they have been 20 foot in height to allow for a 2-story residence. I think I saw a slide earlier that showed a 2-story. And site-specific engineered with even some more additional design provided by a professional architect. So what is the right way to analyze these structures? If a master design is used, then, which is typically only for risk category 1 buildings, then that is done to an envelope of loads based on the number of states that the master design is signed and sealed for. And it should be done to the latest codes that those states adopt. And when states adopt codes, whatever version of, say, the residential or building code that they adopt, they will also have state amendments, and those have to be addressed. And of course, the master design is signed and sealed. Site-specific design is done on a case-by-case basis. It is looking at the loads and codes applicable to a specific address. Really, in both instances, the calculations performed for master design or site-specific design have to be able to withstand the scrutiny of a peer review. This can occur because of an engineering board, maybe reviewing the calculations, or, God forbid, an expert witness from an opposing lawyer. These, as has already been mentioned, these structures are not addressed in the International Residential Code. In the International Building Code, design processes are addressed. High-strength cold-formed steel or steel design along those lines is addressed, but not carport structures per se. So what we typically find is that we are designing the masters in accordance with the building code. And that's because you're signing and sealing for a multitude of states, and it's being mass-produced and shipped, possibly across state lines. So the international code is going to apply. Site-specific is going to be, depending on whether it's a residential structure or a commercial structure, going to be per either the residential code, state-adopted residential code, or state-adopted building code. To supplement engineering design, the engineers should encourage university-level, real-world testing of these structures. As I mentioned, these structures not being addressed in the code require that the engineer not only utilize their engineering judgment as far as behavior. Maybe they're going to use an allowable stress design approach, or a load reduction factor approach, or a limit states approach. Regardless, they're assuming how the structure is going to behave. Real-world, university-level testing can confirm that behavior. It also can confirm the performance of materials and how they're put together. And I'm certainly going to talk about that more shortly. For barn dominiums, which I know has been talked about already this morning, engineers must have the assistance of licensed architects. They're the ones trained in moisture control and insulation requirements, and it's an integral part of barn dominium design. It also comes into play in commercial design too. Not to mention that the architect for a commercial project is going to develop a life safety plan, a code review, things that again, engineers are not trained to do. For residential, I heard the floor plan mentioned. Again, you need to know where those sleeping areas are, routes of egress, and again, the requirements for moisture and temperature. Continuing, that right way to analyze and design is what kind of documents are need to be developed. Well, on a master package, it's typically shown on 8.5 by 11, and the design is signed and sealed. Now, it was mentioned earlier that the North Carolina Board had rendered an opinion that a master design, a risk category 1 structure based on a master design, is acceptable if the master design is treated or can be considered like a set of shop drawings, which means it must be bound and it, again, must be signed and sealed. I forgot to mention, at one time was licensed in 37 states. Been kind of giving those up since I retired. And I've had these same conversations with other state boards, and they are aligned with the thinking of the North Carolina Board. Typically, site-specific drawings are shown on larger border, 11 by 17 or larger, really depending upon municipality requirements. Again, each sheet of those of the site-specific design needs to be signed and sealed. When required, and there have been at times requirements, mostly by government agencies, what's referred to as a CSI format or a Construction Standards Institute format specification, performance specification, needs to be generated. And it'll be in the 13,000 series because that's where performance specifications for red iron pre-engineered metal buildings, or PEMBs as they were referred to earlier, that's where you're going to find the specifications for those. This is an example of master design analysis. The cover sheet of the analysis should address the envelope of loads, the states that the package is being signed and sealed for, because again, you need to check, the engineer needs to check those state amendments that could be in addition to or contrary to the international code. It certainly should list all references and so on. A typical cover sheet for a set of master design calculations. Then, the body of the calculation should be a thorough analysis of the structure. Every aspect of it, stability, connections, foundations, so on and so forth. It should address foundation design as well, connection, anchoring design. And again, this would be in accordance with the envelope of loads that is being designed for. So an example of master design drawing would be, again, a cover sheet clearly stating what the design is for. Many times master designs are revised. This one in particular, this one is up to revision 5. You will see the states that the master design is applicable to. So each and every one of these states, the amendments adopted by these states have been checked against, again, the multitude of international codes, possibly one state using 2018, another one using 2021, and so on and so forth. This is very important, the drawing index, because this prevents insertion or deletion of sheets in the package. And that's why also the package needs to be bound. Okay, this is a requirement by the North Carolina Board and the other boards. The next sheet typically is has installation notes, material specifications. This all needs to be there as well. The building officials, they want to know what your loads are. That was talked about already earlier, and material properties and so on and so forth. So that needs to be part of those master drawings as well. After that, you're going to see elevation views, section views, sections and details, so on and so forth, necessary to fabricate these structures. And finally, you should see an envelope foundation design as well. Lesser loads require, lesser wind loading, for instance, requires the smaller foundations. Greater wind loading, that higher end of the envelope is going to require something larger. An example of a site-specific design analysis is similar. You should see that cover sheet, this time listing the specific loads for that for the state or at the site location of the building. Again, also applicable code and other design reference software or other design references. You should see a good thorough analysis. Most site-specific structures are 3D analyzed. You want to look at the behavior of the entire structure. You're looking at live loading, dead loading, wind loading, snow loading, seismic loading, and all the provisions required in typically ASCE 7, which is referenced by building codes. And again, a specific foundation design and anchorage for that design. So an example of site-specific drawings are something like this. You're going to see this again on a larger border. Each individual sheet signed and sealed. The cover sheet should have general notes clearly describe the loads as well as material specifications and properties. After that, you're going to see elevation views of the structure, sectional views of the structure, details, all of this having been engineered in those calculations. You're going to see a detailed foundation plan and foundation sections and details. And that constitutes a site-specific design. Example of a performance specification. I realize this is probably pretty new to most fabricators, maybe most of the folks in the room. But that, a master CSI format performance specification, when required, is generated to, again, give requirements relating to workmanship, quality control, and so on and so forth. Now, I mentioned earlier about real-world university-level testing. This has already gone on in the industry, but more needs to be done. And in this particular case, the university was evaluating the behavior of wall and roof panels for these buildings. And we were looking also too at different fastener patterns for these buildings. And as you can see, what they're doing is they're testing to failure. They're letting us, the engineers, know your design assumptions were on target or not on target. Your design analysis methodology is on target or it's not on target. We need this input as these structures progress. I've showed you, they progress from a very simple structure to pretty complicated large structures now. Which, by the way, the carport industry and Surrey County, being the founding area of it, should be very proud that the entire country is looking at what we are doing here. And we have the opportunity to set guidelines and so on that the country is going to follow. Here's I love this picture. I know it's kind of hard to see on the screen, but it shows that classical, structural engineers, we like it, but it just shows that classical behavior that we're looking for that yields shear diaphragm information. So now, when we're looking at lateral and longitudinal stabilities of these structures, we can actually see that the panels, not that we, by our gut, know that they're adding strength and stiffening to buildings, we know that. We just have never quantified it. We're now quantifying it and learning the shear diaphragm capacities that are helping us to economize and optimize these structures. We're even looking at the behavior of the tube at the base rail, the legs, the rafter members, the trusses. We're looking at the behavior, deformation, confirming what our assumptions are regarding how it's behaving at the connection between the columns or legs and the base rail post and the anchor. So, now what is the right way to fabricate a building? First, a proper facility needs to be provided. Okay, it's got to accommodate and segregate receipt and confirmation of materials that it's receiving, the fabrication process, which is almost like an assembly line process, and then the staging for delivery. All of that needs to be accommodated, so it needs to be a facility that can allow for that. The fabricator should develop a QA/QC plan for the fabrication of buildings. This is important. That QA/QC plan should address, as I mentioned, receipt of materials, that they are the correct materials, and that they're being staged properly. I failed to mention this, but I've been practicing for 35 years. The last 15 years in the carport industry. And I I'm not going to say I've seen it all, because every time I say that, something new comes along. But I've seen a lot. One of the things I've seen is that when the engineer designs the structure and is assuming that the materials, say for instance, the material used in the tubes are 52 or 54 KSI material, and what we find out is that what's actually being shipped and used in the structure is 33 KSI. So if the design, if it's fabricated in accordance with the design, it's almost half as strong as what the engineer has designed for. Therefore, it's not going to carry the loads that the engineer has designed it for. It is critical that the materials be checked to make sure that they are what the engineer is assuming and using in their design. QA/QC plan should address minimum worker qualifications for performing the work and periodic auditing that the manufacturer should do against its own QA/QC plan. The QA/QC plan should be reviewed and revised a minimum of annually. Technology changes, the fabricator learns they can do something a little different, a little better, and that needs to be reflected in the QA/QC plan. It needs to be updated. And it should also establish minimum requirements for installers or erectors of their buildings. To continue, the QA/QC plan should specify that installers, erectors, meet minimum licensing and insurance requirements to install their buildings. And the fabricator should belong to any governing industry body that is responsible for establishing minimum requirements. Such an organization, as of today, does not exist. Consider the PEMB, or the Red Iron Metal Building Industry. The MBMA, Metal Building Manufacturers Association, exists and sets those minimum standards for manufacturers of those types of buildings. Most engineers and architects, when they develop a performance specification for those types of buildings, require that those buildings be MBMA certified. This industry needs to get to that point. It's not there yet, but it needs to get to that point. Every building produced by no matter which manufacturer it is needs to meet these minimum requirements. Until such time as that is created, the fabricator should meet minimum requirements set forth by the municipality, city or county that the building's being erected in. So the municipality can consider a registration process similar to the city of Houston, and I'll talk about that in just a moment. And that registration process should be updated annually. So here's an example of a QA/QC plan. The first page of it should indicate that this is a controlled document, which means that if it's revised, every earlier version is collected and destroyed. Every worker, manager, and so on and so forth only has the latest one in their hands. It's signed off by those responsible for the QA/QC plan and for the fabrication process. And clearly the revision and date needs to be there as well to confirm that it is the latest document being used. Now, there are certain critical things that a QA/QC plan needs to address. Of course, control of the manual itself, the management structure of the company. Who do the workers report to? When they're doing, who's their supervisor? Who's that person's supervisor? So basically, there needs to be a management structure defined in the plan. How are the drawings that are being developed by the engineers, how are those being controlled? How are those being handled? That needs to be addressed. Of course, work orders received from customers, procurement of the materials and sub-assemblies that are used in the buildings, receiving inspection. Again, that harkens back to what I had said about verifying that you are indeed receiving the materials that the engineer has relied upon to perform the analysis. Otherwise, it'll just be a breakdown. Normal and special control, non-conformities, nobody's perfect. How do you handle those? Corrective actions when they're encountered. A final inspection before shipping. Just making sure that everything is right before it goes out to the plant. Maintenance and control of the equipment. It doesn't make, you can have as accurate drawings, accurate analysis and drawings as you want, and intend the best building in the world. but if your equipment hasn't been calibrated, it could be making a structure that just isn't coming together very well. And I've certainly seen that as well. And then lastly, records, maintaining of records. Again, consider that you can be audited by anyone at any time, as I said, including state officials, or God forbid, an opposing attorney if a discovery is going on. I'm going to talk about the city of Houston and what they do. They were just like we are, and they were struggling to get their hands around how could they stop some of them or prevent some of the complaints that were being made, and this is the process they adopted. It's a three-form process. The first form being basically general information about plant, responsible parties, I mentioned those earlier, and of course some other information. This next sheet here is where most of the work occurs. An independent third party, typically a registered professional engineer, is going to inspect the QA/QC plan. Is it meeting those requirements I mentioned earlier? Also, are there any municipality-specific requirements that the QA/QC plan needs to address? And then there's a plant inspection performed by that person, that party. Again, auditing really against the QA/QC plan that the company has generated. Are they following their own rules, so to speak? After that effort is done, it typically results in this, a letter being written by that third-party inspector to the municipality saying that this fabricator meets all of those requirements. And then it results in this. The municipality maintain list of qualified fabricators. If your name is not on this list, by the way, this is page 1 of 21. If your name is not on this list, when you go to apply for a permit, building officials have a way to check this. And if the building's manufactured by someone not on this list, no permit is issued. What is the right way to install and erect buildings? Well, the person directly responsible for erecting the building is the one who needs to pull the permit. I know that's already been mentioned as well, and what those requirements of that individual need to be. They should carry proper amounts of insurance and bonding. Again, they should be, this is applicable to residential structures. In the past, installers or others have convinced homeowners to pull permit. Now, if it's a structure that is covered in the prescriptive International Residential Code, that's not a problem. Prescriptive is a fancy word for cookbook. So in other words, the person knows that they can look, as was referenced earlier, maybe look at a 2x joist member for a given span. If it's a living area or whatever, they'll know what the load is, and they can pick and choose the correct member. The building official is going to go out there and check that against the code. If it's good, great. If it's not, it's not. You will not find any information about carport structures in the prescriptive International Residential Code. So that building official cannot do that. That same logic should apply to the homeowner. They are ignorant of the code. And maybe they're not ignorant of the code, but they still are ignorant of the structures. So they should not be allowed to pull permit. This has to stop. The person putting the building together or erecting the building in the field needs to be the one to pull that permit, and they need to be properly licensed. Furthermore, that erector or installer needs to be properly trained by the manufacturer of that particular building. Every manufacturer represented in this room has ingenuity. They have their way of doing a structure. There's a lot of similarities, but there's also a lot of differences. So he needs to be trained on by the manufacturer of the building that he is installing. This one irks me. I cannot tell you how many job sites I've been out where we're asked to take a look at the structure. Maybe the building official has grown a little uneasy. We're asked to go look at the structure. I go out there, I start seeing things that aren't in line with the design drawings. I have the design drawings for that building in my hand. I asked the installer, he's never looked at the drawings. He's simply gotten the package from the manufacturer, and he says, I've been doing this for 15 years, I know what I'm doing, okay? Any other job site you go out on, and Keith will correct me if I'm wrong, if you go out onto a job site just about anywhere else, there's a job box, and it has the permit in there, and it has the construction drawings, the working drawings in there. That needs to occur with a carport project as well. There's no reason to exempt the carport industry from the same requirements being met by other industries. That GC needs to be on the site inspecting the work. Now, I believe, I'm a professional engineer, not a general contractor, but I believe there's probably a requirement that a person performing general contractor duties is responsible for being on a job site a certain amount of time to supervise the crew, to supervise the work being done by others. They need to be on the job site. And then do not vary from the design documents. This has happened too many times as well. And almost every time it's led to a problem. That installer or erector should not vary from the plans, not one bit, without written permission from the fabricator. The fabricator in turn should not authorize that without written permission from the structural engineer of record. Now, the last part of the puzzle is the dealers. Now, the dealers are unique to the carport industry. They're typically sold. They typically sell most of the carport buildings. Currently, dealers are not required to have any engineers on staff, nor are they required to be trained by the manufacturers that they represent. Now, those fabricators may require a dealer to do something like that. There certainly isn't any other driver. They're not required to be licensed contractors or anything like that, maybe other than to carry a business license. Historically, dealers have agreed to changes in the structure as they are negotiating with the homeowners or the customer, and many times do this without feedback from the fabricator or the structural engineer of record, and this has led to problems. I'm going to talk a little bit in contrast. The red iron pre-engineered metal building business, or the PEMB industry. You don't see this. What you see instead is that most of the pre-engineered metal building manufacturers utilize general contractors. A general contractor may become an authorized installer of a Nucor building or a Varco Prudent building or some other manufacturer. But that general contractor is responsible for pulling the construction permit, and that manufacturer is solely responsible for the analysis and design, including any changes that may come about that the customer may make. So there are no unlicensed entities or individuals in that process relating to PEMB. We need to approach that with the carport industry. And I know it's contrary to what's going on right now. The carport industry had humble beginnings and has come up the way it is. The pre-engineered, I really don't know what the beginnings of it were, but I do know that they're not facing the kind of problems that the carport industry is facing today. Those dealers should be factory trained by any fabricators they represent, and they should be required to carry the same limits of insurance as the fabricator, and furthermore, list the fabricator as an additional insured. If the dealer is going to want to make changes to the structure to accommodate a customer, they either need to have a registered professional engineer on staff or certainly coordinate it very closely with the fabricator and the structural engineer of record. If the dealer also intends to be the entity that erects the building, and I know there are some dealers that do that, they need to be a licensed general contractor. They need to be the ones pulling the permit. So a summary of my recommendations. The Again, analysis and design, all the documents need to be signed and sealed. Furthermore, the structural calculations need to be submitted to the fabricator along with the design drawings. Now let me tell you where I'm coming from on that. I have firsthand experience with a project where the customer received the signed and sealed drawings in accordance with their municipality requirements. When the calculations were requested, they were told, oh, that's going to be an additional $2,500 and take another 3 weeks. What does that tell you? They were not done. So those drawings were plan stamped, which is a violation of state engineering law. We don't have anybody with the engineering board here, but they can certainly attest to that going on. Submitting the structural calculations directly to the fabricator. Then either the fabricator or the engineer of record with permission would be the ones to provide those directly to the building official. The building official will not release that to the public. If a performance specification is done, it too should be submitted as signed and sealed. And I have seen this happen. Whether it's the customer or someone else gets another engineer involved, that anything to do with that structure needs to be done by the structural engineer of record. Okay? They're the ones responsible for the behavior of that structure, and it clouds the water a lot when you get another engineer involved. For barn dominium projects, require that a licensed architect be involved. Again, they're the ones that are trained to address what I've already talked about, and they would generate their necessary documents, which would be included in the drawings provided to the building official for permit. For a fabricator, develop a QA/QC plan. All the processes should be audited against that plan. It should be updated and revised annually. Become a registered fabricator within a municipality should that municipality adopt a registration process. Again, this would maybe go on until such time as we have a governing body such as the MBMA for the carport industry. And then that's pretty much, once one's established, then be part of that. For installers and erectors, require that the installers be a licensed general contractor if they indeed are the ones erecting the building. And of course, they have to be on site, observing the work, observing their crews. Require that they carry the proper amounts of insurance and/or bonding. Require again that the latest design documents are always on site along with the permit. And then of course have proper training by the fabricator of the building that they are installing. For dealers, require that dealers carry the same limits of insurance and/or bonding that fabricators carry. Require that dealers have a licensed professional engineer on staff if they intend to make changes to the structure with the customer. If the dealer intends to erect the building, they need to be a general contractor. And of course, again, be factory trained for whoever they're going to represent. Now, I've just laid out some major changes to the industry. These are my professional opinion. And you'll notice I didn't talk about the wrong way. But basically what I'm saying is anything done contrary to what I've defined is the wrong way. I'll tell you a little story. There was a treasury agent who was asked by someone, how can you study all of the different ways to make counterfeit money? You know, there's a myriad of ways to do that, and a myriad of and he said, we don't. We study the original so well that we know when something else doesn't meet it, okay? We need to start doing things the right way. And we're gonna see a lot of the problems that have come up go away. And nothing's gonna be perfect and no one is perfect, but at least we can take care of a lot if we would just implement some of these requirements. And I thank you.
Good afternoon, everybody. For those of y'all that don't know, my name is Reed Plott. I'm an engineer at Moore & Associates. Before I get started, I want to thank Keith for organizing this today. I think this is a great opportunity for everybody to come together and share information and then start moving forward together into the future. So I'm going to talk to you a little bit about maybe the technical aspects of carport design, give you maybe a little bit of a behind the scenes look into what we do when we're designing these structures. But first of all, in general, what does an engineer do? I was reading an article recently about the Francis Scott Key Bridge that collapsed in Baltimore, and a University of Delaware professor had this to say. He said the number one job of structural engineers is to protect the public and minimize the risk of structural failures that pose a threat to human life. To do that, engineers must be able to calculate the forces that our structures may be subjected to. And then interestingly, he went on to say that design codes are continually updated to account for new knowledge, new materials, and new design techniques. For those of y'all that worked with us, you might have recognized that over the last year and a half, our designs have changed, even though the building codes haven't changed significantly. This is due to new design techniques that have been implemented. So I'm going to talk to you a little bit about snow loads and wind loads, the loads that the structures are subjected to. Then talk to you a little bit about how do we determine if a structure can withstand those loads or not. Then I want to talk to you a little bit about how not all steel is created equal, especially in the cold formed steel industry. And then I'll have some concluding remarks at the end. So section 1608 of the International Building Code governs snow loads. Apologize. It states that design snow load shall be determined in accordance with Chapter 7 of ASCE 7. This is just a cover page of one of the ASCE 7 codes. I'll talk to you a little bit more about the ASCE 7 code later. Further on in the Building Code, Chapter 1608, you'll find a map of the United States with different ground snow load requirements. If we zoom in on North Carolina, you'll see that here in Surrey County, we have a 20 pound per square foot ground snow load requirement. At the coast, we have a 10 pound per square foot snow load requirement. But that's ground snow load. Ground snow load then gets converted to a flat roof snow load, which then gets converted to a sloped roof snow load, which is the actual load applied to the structure. So even though the ground snow load is 20 pounds per square foot, that doesn't mean that there's 20 pounds per square foot of load on the roof of the building. Here's an example of one of our analytical models showing a gravity load. I'll go into a little bit more information about our models later when we talk about the analysis. While we're talking about snow loads, I think it's important to talk about snow drift, which is a phenomenon that does come into play in carport structures. Basically, snow drift is when snow builds up against a taller structure. If you zoom in, this picture on the bottom has an upper roof and a lower roof with this triangular load, which is the theoretical way that we model snow drift. And I'll have an example here of a real world snow drift. So you can see the lower roofs of this house have a buildup of snow adjacent to the taller structure. That is a snow drift, and that's additional load that gets applied to the roof of the structure that we have to account for. It varies across the country, but here in North Carolina, the density of snow is roughly equal to 16 pounds per square foot per foot. So every additional foot of snow that sitting on top of a building, that's an additional 16 pounds per square foot of load that roof has to support. So how does that affect carports? A lot of times carports are manufactured with a lean-to with one roof lower than a higher roof. So you can get a snow drift to build up here, and that has to be accounted for in the design. If you have a roof extension lean-to, there's no drift consideration because you don't have any taller structure for the snow to build up against. Similarly, if you build a carport structure adjacent to an existing structure, taller structure, you can get a snow drift build up. That should be accounted for in the design, and as a manufacturing fabricator, you should be aware of these conditions so they can be accounted for correctly. So that's kind of a gravity load, stow load issue. Now let's talk about wind loads. Section 1609 of the International Building Code states that building structures and parts thereof shall be designed to withstand the minimum wind loads prescribed herein. And then it states wind loads on every building or structure shall be determined in accordance with chapters 26 to 30 of ASC 7. So that's that same code we talked about earlier, just a different chapter. Also, I want to point out, it specifically states that decreases in wind loads shall not be made to the effect of shielding by other structures. So even if the building being designed sits in the middle of a bunch of taller structures around it that might practically block some of the wind, the building code says we cannot take that into account in our design. It has to be designed for the same wind as any other building. So similarly, if you go further in the building code, you'll find a map of the United States with design wind speeds. This particular map is for risk category 1 structures. There are different design wind speeds for different risk categories. But just for an example, we're looking at risk category 1. We zoom in on North Carolina. As Pat was mentioning earlier, there's a 140 mile an hour wind speed requirement at the coast. It decreases towards, as you go inland. Here in Surrey County, we have 105 mile per hour design wind speed. I want to point out too, the special case study that Pat mentioned earlier, at some of the higher elevations where it's a lot windier than the lower elevations, you have these special case study areas shaded in gray, where the local municipality will determine what the design wind speed is. So that's wind speed. How does that get converted to an actual force applied to the building? Well, wind speed then gets converted to a velocity pressure, which then gets converted to a wind load, which is that lateral force that actually gets applied to the building. Some of y'all might have heard or seen the terms nominal wind speed versus ultimate wind speed. I don't want to get into the weeds, but just suffice it to say that nominal wind speed is kind of the older method of doing things. Some of the older ASC 7 codes reference nominal wind speeds. The newer codes reference ultimate wind speeds. So new codes, new designs are using ultimate wind speeds. So what happens when the wind blows on a building? The left-hand figure here is a plan view, so you're looking down on a building. The wind is blowing to the left. The wall facing the wind has this pressure that wants to push the wall inward. The wall on the back side has this suction phenomenon where that wall wants to get pulled away from the building. So there's two lateral forces going on there that we have to account for. On the right, that's kind of a cross-section of the building. Same thing, wind is blowing from the left. You can see the wall facing the wind has this pressure trying to push the wall inward. The back side has this pressure trying to pull the wall away from the building. And in the roof, you have both an uplift and a down pressure effect that has to be taken into account. Open buildings, there's no walls, it's just a roof. Again, you just have this uplift and down pressure effect on the roof caused by the wind blowing horizontally. Again, here's one of our analytical models showing a lateral wind load applied. I'll go into a little bit more detail here in a little bit. Similarly, from a wind's perspective, there's also this uplift force that has to be accounted for, or a down pressure force, whichever controls. This is just to show how we model that in our analytical models. Also want to point out, there is a minimum wind load that has to be applied to these buildings. ASC 7 states essentially that walls have to be designed to withstand at least a 16 pound per square foot wind pressure, and roofs of enclosed buildings have to be designed to resist an 8 pound per square foot wind pressure. For open buildings, again, there's no walls, it's just a roof, but the code says that open buildings have to be designed for a 16 pound per square foot wind pressure applied to the roof. So what does that mean? Basically, that means even though your wind speed might be 105 miles per hour, and you have a calculated wind pressure of 8 pounds per square foot, the building code says you have to design the wall to at least withstand a 16 pound per square foot pressure, which may be the equivalent of, say, 130 mile an hour wind. So even though your design wind speed may be 105 miles an hour, you're essentially designing it the same way as you would a building with a site with 130 mile an hour wind speed. Those aren't necessarily equivalents, that's just an example. I just want to point out that there are some minimums that we have to take into consideration. And here's just a diagram showing the 16 PSF applied to the walls in an enclosed building and the 8 PSF applied to the roof. of an enclosed building. So Pat kind of pointed on it, or touched on this earlier, so maybe this will kind of reinforce that or give you some more information. If you want to know what the design wind load or wind speed and snow load requirement is for any site, you go to asehazardtool.org. You'll find this prompt, like Pat said, you put in your address, you select what code you want to use. I'll share that the 2015 International Building Code referenced the ASC 7-10 document. 2018 and 2021 versions of the International Building Code reference the ASC 7-16. So the ASC 7 code gets updated periodically as well as the building code. So you need to know which code you're referencing. There is an ASC 7-22 code published, but currently none of the building code has not adopted it yet, but I'm sure it will in the next update cycle. Again, you select the risk category for the building, what kind of load you're looking for. You're looking for a wind load, snow load, seismic, anything else. Click on view results. You're going to get this. It's going to spit out a design wind speed and ground snow load. That's what's required for that particular property. So let's talk about loads applied to the building. So now how do we determine if the building can withstand those loads? We look at stress and deflection. So stress is the amount of force applied to a member and the amount of force that a member can withstand. And then deflection is what's going to occur when that force is applied. How much movement is going to occur? The amount of movement is called deflection. So going back to one of our models here, we have a lateral wind load applied. This is just typical frame. We have knee braces, columns, rafters with some rafter ties and vertical struts, pretty standard stuff. When we analyze stress, we look at every single member in the structure and we compare the force applied to that member versus that member's capacity. So the ratio of force applied to capacity has to be 1 or less. Otherwise, the member is considered overstressed and it will fail, the model fails. So here are our columns. The utilization ratio is 0.983. That's the limiting factor for this model. Everything is less than 1, so everything's good to go. Similarly, we look at deflection. So the black line is the original shape of the structure, unloaded. The green line is what's going to happen to the structure after the load is applied. So if we zoom in, we see that the column is going to deflect to the right, and the wind load is blowing from the left. So we look at these deflections and make sure they're within serviceability limits outlined in the code. So not only are we looking at the strength of materials, we're looking at the serviceability of the material of the building to make sure that it's moving too much and that it essentially becomes uncomfortable to be in. So now I want to talk to you a little bit about steel. It's already been mentioned a little bit before, but there are different types of steel out there, and it's important that the steel used matches the steel used in the design of the structure. Most cold form steel that we see is being manufactured in accordance with ASTM A653. And this basically just states that steel manufactured according to this standard has a certain chemical composition and certain mechanical properties. Chemical composition affects the weldability of the steel or the strength of the welds. Mechanical properties affects the strength of the material itself. There's a couple different types of steels outlined in this standard, but commercial steel and structural steel are the most common, the ones you're probably more familiar with. I want to point out some of the difference between CS grade and SS grade steel. So we look at chemical requirements for CS grade steel. Just for the sake of this presentation, just look at the carbon content. It's anywhere from 0.02% to 0.15%. And if you look at the chemical composition for structural steel, it's anywhere between 0.2% and 0.5%. So an order of magnitude more carbon in the structural steel. And not only that, it's not a range of carbon, it's a minimal carbon content. Similarly, if you look at the mechanical property for CS grade steel, yield strength is going to range anywhere from 25 to 60 KSI. But more importantly, the code says specifically, or the standard I should say, these mechanical property values are non-mandatory. Values outside of these ranges are to be expected. So when your CS grade steel has no guaranteed yield strength. which is important, especially when you go into design structure and you're making an assumption on the yield strength of the steel that's going to be used. Similarly, if you look at the mechanical properties of SS grade steel, yield strength ranges anywhere from 33 to 80 KSI. Most designs use a 50 KSI yield strength, which would require an SS grade 50 steel. But these are minimum values, so whereas on CS grade, it gives you a range of yield strengths, none of which are mandatory. SS grade says, this is the minimum yield strength. You can have something greater than 50, but it is never going to be less than 50 KSI, which is important. Again, if the structure was designed assuming a 50 KSI yield strength and 40 KSI is used, that structure is not going to behave the way it's intended. So to summarize, when we design these buildings, we first determine the snow load and the wind load applied. Then we determine the material properties, what's the yield strength, what types of tube is being used. Then we analyze stress and deflection utilizing structural engineering theory, supplemented with empirical test results, some of the university testing that Wayne had mentioned earlier. And then we use our analyses to inform our structural drawings and specifications. So I recognize we're going to have Q&A in a little bit, so why don't we hold questions for this afternoon. But before I leave, I want to touch on some of the things that Wayne mentioned. I want to talk to you about some of the benefits of having some kind of industry trade organization. Again, akin to the Metal Building Manufacturers Association or the Red Iron Metal Buildings. One, it would create a unified set of design standards like Wayne mentioned, kind of create a level playing field for the industry. It will provide certifications to its members. So if you are a member, you'll get a certification that you can share with your customers, which will help set yourself apart from the competition, maybe instill some confidence in your customer, maybe help you make a sale. It'll set a barrier to entry. So people that are not certified will have to jump through the same hoops as everybody else to get certified. And along the way, they'll learn about the right way to go about designing and erecting these buildings. And then once you are a member, it'll provide guidance and help answer questions you may have. It'll provide industry leadership. It'll promote the industry. It'll help do some marketing. It'll help get Carports in front of more people, which might help increase sales. Again, it'll help perform some research and education training, provide training opportunities for its members. But the key is that this type of organization has to be created by the members for the members. So all the manufacturers here have to be the ones to come together and create this industry or this organization to help govern the industry. And dare I say, it's better for you to regulate yourselves than it is to have the regulators come in and regulate you. So it's good for you. I think it'll benefit everyone involved. It'll help drive sales. It'll move the industry forward. Instill more confidence to the general public. I don't see it being a bad thing whatsoever, but you as manufacturers have to be the one to create this and get it up and running and participate. So I want to challenge everybody in here to be a leader in their industry. Please consider the formation of some kind of industry trade organization. Keith mentioned a Surrey County Metal Building Manufacturing Association. Maybe that's a good step, but I'm dreaming bigger. I think it should be a nationwide organization, again, akin to the Metal Building Manufacturers Association, that will help raise the bar, drive the industry forward. I don't see it being a bad thing whatsoever. And that's all I have.
Actually, over 24 years ago, so believe it or not, we've got some experience in this industry as a whole. And Mark has been in commercial construction for probably over 22, 23, 4 years, and he'll talk a little bit about his experience here later on as well. But, when Keith asked, anybody if they wanted to present, I said, okay, why not? We'll do it. Like I said, I was hoping more people would do it, but I'm good with that. So our company, I'll talk about Carport Central because this is a manufacturing type conference. And again, I want to thank Keith for putting this on. It's great to see a lot of people here. Great for the state guys to join us as well to get a little information about our industry. So this is from our perspective of how we see it. Carport Central, first of all, you know, we've been doing this for a while, manufacturing for about 4 or 5 years. But once we got into the manufacturing part, we wanted to do things a little different. We wanted to do things to make this industry grow and go into a different level. So part of doing that, you know, we are affiliated with a lot of different associations, along with the American Welding Society, Old Form Steel and Engineers Institute as well, and some of our present and past customers you can see on the screen there that we service. So we've seen a lot of changes in this industry. You guys already saw the slides from your basic top-only carport right into the smaller garages. So we've seen a lot of that for us ourselves as well. Again, this is how we, pretty much all of us here, manufacture these structures. Carports, RV covers, barns, garages, like we saw in some of the presentations as well. And then as well as garages. Now when we talk about garages, you know, most people park their car, 1 or 2 doors, and that's it. We're seeing a lot bigger structures where they even go into the risk category 2 realm as well. So we have been talking about risk category 1 structures, and what I'm going to talk to you guys about is our journey basically. And now we're seeing more risk 2 structures, larger structures. Obviously from this also we go into more of the commercial area as well, commercial structures, commercial storage, and a little bit I'll show you some commercial projects. But it's just the evolution that we've seen. So basically commercial storage, you know, where a business comes to us and they need extra storage for their product. Again, from commercial storage, we also graduated into commercial structures. A lot of different commercial structures that we've done over the past couple of years, but this in particular one, we're talking about a church as a commercial structure. So it's hard to believe from that one open top to a structure that now, you know, is a place of worship. So there's a lot that goes into this type of fabrication, and obviously the engineering behind it as well. So from this, you know, this industry is evolving a lot, particularly for ourselves. Like I said, we've seen a lot of shift, a lot of changes. Mostly, I've seen the slides, and believe it or not, we did not get together and say, okay, let's talk about this and let's get all together. And it just seems coincidental that, you know, we've talked about the barndominiums, the metal homes, the residential part. So for us, our journey has been more into the research and development of these structures, because over the past 3 or 4 years, believe it or not, a lot of our fabrication, a lot of our structures that go out every week from our plant, it's about 2 to 3 of these residential structures every week. That's a lot. 2 or 3 homes go out every week from us. Now we service a lot of the country, you know, all the east and southeast. So a lot of this you don't see in North Carolina. You see a lot of different areas. But before we got into this fabrication process, we wanted to make sure that our product was safe, make sure that our product meets all the codes and requirements. So from the fabrication to the engineering and the research and development, talked about floor plans, then now comes the residential. So again, we are doing these every week. So part of that research and development taught us, okay, how do we make sure that these structures are behaving the way they're supposed to? How do we do that? Well, again, I'll let Mark kind of talk a little bit about more of what we're getting into now with his experience and a little bit of his background as well.
Good afternoon, guys. I'm Mark Hyatt. I'm a PE, and I work with American Building Network. We're under the Central Steel Group of families owned by Jay and his brother Howard. Today I'm going to talk a little bit about energy code compliance and our risk category 2 structures. As Jay's mentioned, American Building Network will manufacture between 2 to 3 metal homes and 3 to 4 commercial buildings each week. These structures are different than our carport and utility structures, whereby our carport structures present a low hazard to human life and are not intended for occupancy. These homes and commercial buildings are considered to be risk 2 structures and are intended to be occupied. Like most in the industry, in order to assist with our customers' permit needs, we provide our engineered master plans for the size structure that the customer is intending to build. Our master plans are basically assembly and connection details for a certain width of building, and then our master plans, though, only apply to the shell of the structure. What we've been seeing in the past few months is many building inspection departments in our service area are requiring our metal home and commercial customers to provide documentation of energy code compliance and how these details will be achieved in our high street tube steel buildings. So here at ABN, and specifically for the state of North Carolina, we partnered with a local architect who has performed a thermal energy compliance analysis of our structures. The research and analysis ensures that our structures can meet the IECC compliance requirements for our local thermal zones here in North Carolina. We will share this information with our customers to ensure that the homes and commercial buildings that ABN manufactures will be code compliant when finished. So if you're manufacturing or selling metal home packages or commercial buildings, you need to be sure they're constructed in such a way as to comply with the energy code requirements in the area that it's located. Otherwise, your customers will likely be in for a bad experience.
So, like Mark was saying, we try to comply with every facet of the design criteria, as well as you've seen some of these slides already in the prior presentations. Now, what we did is we partnered with the major university, and we wanted to make sure, are they doing what they're supposed to be doing? So, as you can see, we pretty much took this product and destroyed it and have all that data that we use in our designs and our structures. So because of that, we can honestly say our structures are 20-30% stronger the way we fabricate them with the materials that we use and the design process that we use. So our structures are designed to not only withstand local loads, but a lot of additional loading as well. That's how we feel safe that our structures will meet all these criteria. So part of that, along the way that we learned as well, is in order for us to do that, obviously we have to have some kind of quality assurance, quality control plan as well, which we've been doing for a while, in our plant. So we've streamlined our manufacturing process to incorporate a lot of these quality checks and controls, down to the point where we have quality assurance people that make sure everything's ready for the installation crews to load up, everything's ready to go for them as well. So again, it's been a process for us to get to where we're at, and I feel like, some of the things that we're going to be talking about here in the question and answer session is, how can we make this better? What can we do for this industry to be not just local or statewide, but really nationwide, and for us, maybe international. So, we're looking at a lot of different things.
Going back to the testing slide that he was showing earlier, but basically what we did, we constructed welded connections and braced assemblies from our tube steel products. As you can see, we even built wall and roof assemblies, applied sheeting on them, and then they were tested in tension and compression loads until they failed. And basically what we found out is that our materials did not enter failure mode until the applied loads were well in excess of what would have been considered a design load.
So with that being said, I think we're all here to try to make it better, do something different. So some of our concerns, now this is, from us, and you guys may have the same concerns we do. Our concerns, for example, a lot of manufacturers or people coming into the business don't understand what it takes to do the major manufacturing like some of you guys do, like we do. So not following proper design specifications are concerned, not properly licensed and insured. Obviously, we have to have everything in order for us to do the things that we do. Not using design-specific materials. So like I said, for us, we have specific materials we use, we have specific designs that maybe other people don't use, but we use them. But they're required in some of the fabrication of homes and, commercial structures, not just for risk category 2, 1, or 2, but we've done a lot of risk categories even above the risk categories themselves when we deal with the Department of Energy. So there's a lot of things that we've learned along our way, but also our concerns, again, go back to, the welding standards. We're associated with the American Welding Association, and our welds are checked, and we have a quality assurance process that we do as well. But fabricating, our concerns are fabricating in residential and non-commercial locations, workplace safety basically. So a lot of the manufacturers now are fabricating in, unregulated areas, like a residential location. So we're not opposed to people starting in this industry. We want everybody to do it the right way and have the safety of the consumer at hand at all times. Another thing that our concerns are unauthorized use of proprietary designs or falsifying drawings. There's many times where we have into legal battles with other manufacturers that basically steal our designs and just white out the manufacturer and the engineering. And I know a lot of you guys in this room have gone through that same process we've gone through, where people are stealing your drawings and using them, and at the end of the day, it's your name on there, and then they're coming after you. So these concerns, I believe we probably all share the same, and being that this is a forum and a roundtable, hopefully more will come out. These are just a few that we have our concerns. Now, from this summit as well, we hope to get some recommendations, not just from our own peers, but also maybe from the state level, if they can help us maybe, guide us in what we can do. So just a few recommendations on our end. Obviously, we can come up with a whole lot more, but same thing, like I said, we've noticed in other slides, probably some kind of approved manufacturer list, or, on the city or county level, where we're on that manufacturer's list where people can go to the county and if they want to pull a permit, they know who we are. Maybe some kind of third-party manufacturer certification process, like Mr. Moore was talking about, like the city of Houston does. Or even possibly a master filing system like Florida does. Their counties are master filed with our master designs, and someone goes to pull a permit. Well, okay, yeah, you're with this company, yeah, we've got your design, what size building? Yes, here's your permit. So something, along those lines. Again, these are just some recommendations we have. We're hoping to get more recommendations from everybody here as well to make this industry better. But again, I want to thank you guys for coming out, because I do see a lot of people that we know, and I know just by being here, you guys actually want to make a difference. And so we're excited to see where we can go from here and what we can do to make it better. And
That's it. Thank you, guys.
You gotta dig in a little bit on that.
That's what I told myself. I ain't got no questions. Half the people ain't gonna like have my questions, and nobody gonna like none of my answers. I'm just here quiet.
Here's your time to ask any question that you want. The stage is here. I'm going to give them the mic, pass around. I'm going to come to you. You can raise your hand if you got a question. Another thing I want to mention, when I was meeting with most of y'all, I could see the pride in your face of your industry. And here's your time to show your pride and do what you can and ask the questions that you need to make your industry better. And that's what this is all about. They came all the way up here for this reason. So here's your time to talk and to speak your mind. So I will pass the mic to Pat right now. If you got questions, raise your hand. If you don't have a question, it's going to be a quick I got one, I'll start one. So, if we have, this is in general, as an inspector, I come out to a site, we have a house or a structure that's been built without a permit. Now, the question is, homeowner didn't pull a permit, whatever. Now, the installer that put that in, should he have found a permit? Are they responsible to know that the permit's there before they put that building up?
Yeah, that's actually not a code question.
Good question.
Yeah, I think it has to work with the general contracting board too. Well, first of all, there's a violation for not getting a permit because the general statute required 160D, that's 1110, require any construction has to start with a permit, and as you exempt from the general statutes or building codes, like a farm building, basically. Now, from whether the installer has to get a license or get a permit, I think Curtis can help with that.
Okay, so I'm gonna jump in on the part about, well, back to the building permit and the fact that one was not obtained and the installer, the fellow who did the work, so to speak, I guess maybe is he on the hook, so to speak, for not getting a building permit? I know from the licensing board side of things, whenever we are perhaps having a hearing of some type and we're considering matters of fact and evidence, the building permit always belongs to the owner of the property. The building permit is tied to the owner of the property. And this comes into play sometimes when we have general contractors to say this, that I didn't get a building permit because I didn't have to, because the building permit is the responsibility of the homeowner. All right, that's kind of how it comes into play. That's what our board reckons with it. And keep in mind, we're still deciding licensing law and not so much who should have got the permit. That's just how this board perceives it and how we look at it. So does that answer that question a little bit?
Yeah, basically, who, would that company, that installer, whoever, would they be on the line or in trouble for putting that building up without a permit?
From where we sit, of course, we just regulate the industry of licensees, right? So if he's not a licensee, there's nothing that we can regulate. It wouldn't be any penalty with our board or any issue of misconduct, so to speak, just because they're not a licensee. Now, if we want to talk to that for a second, if you like, if the installer is indeed a licensed general contractor with this board and part of licensure, our board expects you to know that you have to get a building permit to do the work. Through licensure, through examination, through demonstrating to the board that you're capable and able to act as a general contractor, our board says, well, our licensees have to know when they should have a permit. Now, that being the case, and we do have hearings on this, by the way, issues of misconduct as defined in 8711, if the licensee performs a job or project which requires permitting, then the board will discipline the license. So yes, there is ramifications with us on that part of it. Of course, the severity of the situation for not getting a permit and that the structure was put up not code compliant, had to be demolition portion and rebuilt. If there's civil litigation involved, that's a completely different story. I will say this though, probably in excess of 80% of the complaints filed with the board against a licensed entity or either unlicensed, there's civil litigation that's already occurring, or there's civil litigation that's going to occur based on the board's decision. In other words, we're just a free affidavit to be used in a civil court matter to show the licensee did something wrong, or the unlicensed entity was practically not licensed.
Let's break this thing down one more time. We were talking during break right there. Now, if you've got a homeowner right here, and he pulls a permit, and he pays this man $30,000 to put him a building. Well, no, let's say he pays him $50,000 to put a building up. You know, the total cost of the project might be $100,000. But if he pays this individual $50,000 to put him a building up, he pulls a permit as his own contractor. Does that installer have to be licensed?
All right, the question is we have a, do I need to repeat the question for you? Is this being recorded?
It's being recorded, yeah.
Okay, so the question is if we have a, keep $100,000 project, what'd you say?
Right, let's say $100,000.
We have a $100,000 project, which encompasses perhaps foundation work, things of that nature, and we have a metal building erected, we'll just say, and for his portion of the work, he's going to install and construct work that may be $50,000 worth, right?
Right.
Okay, and I think what maybe you might be pointing to is a $40,000 requirement for licensure. So to break that down a little bit, if you remember when I talked earlier about this 87-1 that was defining when you had to have a license with the board, All it says is the cost of the undertaking for a project. Cost of the undertaking for a project. So, for the building inspectors in the room, if you're looking at, here's a different scenario, but I think it's gonna follow the same principle. If you're out inspecting a home that may be 7,500 square feet, and it's rather elaborate, and the general contractor, or even the owner, has hired a framing contractor to come out and do the work for him. He gives them a price of $45,000 to do the work. He's a subcontractor. The metal building company in this particular case, in this scenario, because there are other aspects of work taking place for which the owner has control of, he's calling the shots, then I don't believe this would be a violation of a board rule. Now, I'm not saying that's the gospel, but the scenario is this. What you're telling me, this metal erection company is just one portion of the total scope. So it may be a license that's not required. Pretty much it's not. I'll just go ahead and say that. But a different scenario, homeowners being owner builders and that sort of thing. We talked about cost of the undertaking. And I'll get to it real quick and fast. And a scenario that probably would require licensure is if the metal building and erection company was hired to come out and install a metal building on that property for which the only work that took place was the erection of the building only. That is the cost of the undertaking. And keep in mind, you probably don't see that a lot because there are foundation requirements most likely for anything probably over $40,000 worth. There's other stuff that goes on. If the metal building company says, hey, my $35,000 building right here it is, I can erect it and set it up for that. And I'm gonna hire a foundation guy to put the footings in, that's gonna be another $15,000. Now he's engaging. He's superintendent managing. Even though it's one aspect, he's hiring somebody else to work for him. He's putting himself into that situation. Did I take off on that a little too long? That's a situation as such. Now, sure.
The issue that we run into as manufacturers is that is not equally addressed through the counties or the states. So for example, some counties take into consideration the retail cost of the building and some allow us to break that down as to actual cost. So when we're using the term cost, are we talking about cost of production materials and installation, or are you talking about the retail price? Because the counties and states view it differently.
Let's speak to that. Let's speak to that as if you were set before a Wake County Superior Court judge and you're not licensed. Here's what he's going to ask for. He's going to say cost of the undertaking. What's it going to cost if you're into a contract for $100,000? Okay, that's your contract. I'm going to construct and manage for you for $100,000. That's the stipulation.
It's the cost to the customer is what you're stating.
Contract cost to the customer.
Not the cost of construction.
If you're building it for $5 a square foot and selling it for $25 a square foot, 25 is what we look at.
And we don't have that concern because honestly, we don't really have that concern in general because we strive for compliance.
Right.
For those that don't know me, I'm Heather. I'm from Carolina Carports. I'm one of the general managers there, and I've been there for 23 years. So compliance is something that is very important to us, not here just in Surrey County, but across the board. Quality control and product quality is very important to us. That is one thing that we refuse to compromise on. That's something that's very, very important. No individual building to us is worth our license, our reputation, or anything otherwise. But we do encounter quite a few inconsistencies as far as county to county, city to city, state to state.
I understand. That portion I can't speak to. I can just speak to licensure.
I'm just bringing that up because obviously the people in this room probably encounter the same thing that we do every single day. And while we've talked about a lot of topics today, especially like the barn doors and things like that, we stay away from that. We don't even like the word. It's not part of our vocabulary. We don't use it. Our buildings are storage utility use only. at most risk category 2. And then our customers are instructed beyond that, that they have to hire their own engineers, architects to bring it up to occupable code if that's what they choose to do. So we steer clear of that. That particular term, in our opinion, has somewhat diminished the value of this industry and caused a lot of these problems that we're talking about.
I have a question about dead loads.
Dead loads?
Which would be, I guess, the engineers. So, I have seen in our industry, some companies who do spray foam insulation, or the customers after the fact, us not knowingly, right, if they're gonna do that or not, will use spray foam. And I have not seen in our master packages a copy of, or an addition to a dead load for spray foam, for example, right? But if we so choose and said, hey, we don't say, hey, customer, you should spray foam the buildings, we offer 2,000 installation and everything. But if they're gonna add spray foam, should that not be an allowable dead load within the master package and or site-specific package?
Sure, so we have designed buildings with additional dead load, but we need to know that up front. Generally, we design with the dead load just for the tube steel and the paneling, and any kind of rafter tie or anything like that. So we would need to know up front if there's going to be additional spray foam or anything. I believe spray foam depends on the thickness, but maybe it's like 2 pounds per square foot, something along those lines. But we would need to know that up front. So if you want that, we can add it to our designs, but we just need to know it. Does that answer your question?
Let me also add, risk category 1 structures are not intended to be insulated because they're unoccupied structures. So we have seen issues where after the fact, these structures were spray insulated, and again, that's caused issues because they weren't designed to be insulated, occupied structures. But as Reed was saying, the engineer should, we refer to it as collateral loading, so above and beyond the dead loads of the materials themselves, any special collateral loads the engineer needs to know about. These can include sprayed-on insulation, they can include hoists, they can include cranes, they can include just about anything. But that does fans, some larger fans and so on. So please make sure that your designer, your engineer, knows all of the collateral loading.
And that's assuming that the customer communicates that. A lot of the times, we don't know those factors and they don't discuss those factors. Especially as a manufacturer, when much of the sales conversation takes place with the dealer. And I know there are a few dealers here represented. The dealers need to be very educated on how to inform these customers what they can and they can't do with their buildings. That's what we see more often than not. We do a lot of cleanup on the back end because the right information is not presented on the front end by the dealerships. In all reality, a lot of dealers are get that quick money in the pocket, put it off to the manufacturer, and then we're the ones that end up managing on back end.
A lot of what you're saying is one of the is some reasoning behind my recommendations that I have made. Certainly, one is that within the purview of either the manufacturer, the dealer, and the installer, that no changes to the design be made, period. Now, if it is done after the fact by a homeowner, I believe it probably would be up to a building official or somehow to take action, but I know a lot of people do things behind closed doors. We tend not to get back involved until a failure has occurred.
But your building's designed at a 2-pound collateral load, and you want to add this, this, and this, and we have to spray foam it. Well, I didn't know that I couldn't do this. What do you mean? And well, you got to go back and talk to. And so it needs to be almost some way that when that building is signed off and bought on, this is what we understand, and if any change, there's got to be some way to explain to them that. I think a lot of people just think, oh, I can go buy one of these things and put it up, and then I can, I can put 500 people in it and then put a sprinkler system and, ceilings and a chandelier and,
That's absolutely what they believe,
Yeah.
because there's not enough information on the front end to clarify that.
Or they've seen one where that was already taking place. and
Exactly.
Yeah, we get a lot, well, so-and-so did it down the road, why am I
Experience
different?
it,
I don't
and
know how to
think
answer that
that's-
one.
It's okay.
I mean, we have one that we completed. It is being utilized as a home. The customer went through all the proper channels to do that. And people think it's a quick and easy process because it's not explained to them thoroughly enough up front. So as I said, we try to stay away from the barn doors. We discourage spray foam insulation, number one, because these are corrugated steel structures. So when you go into spray foaming, obviously you get seepage and it's just not very presentable. So we try to stay away from all of those things. It's more or less a pick and choose your battle type of situation.
I'll add to some of that because this is why we're here today. Part of what we're hearing right now is basically, and I'll speak to what we do as an organization. Our training process for our salespeople and our dealers, mainly our salespeople, it's about a 6-week process. Because there's so much that goes into the things that we do that maybe other companies don't choose not to do, which is no problem at all. But I feel that that's what's gotten us in a lot of position we're at right now, where the dealers are not trained properly. But that goes back to the manufacturer as well, where they have to set the standard for their dealers. And I know some of the online dealers are here right now, where they're facing a lot of pushback from customers, and it's a price war right now because, well, this building's this price and over here is this price. The reason ours are typically higher is because we take in consideration all these issues, and some of our designs already take in consideration what we're talking about. Where other companies don't, it's the minimum loads. It's just the sheet metal and screws, that's it. They don't realize that they can't put, to an extent, certain lighting or insulation. But that's where we're seeing the differences. Our training process, we try to train as much as we can, so that way we don't have those issues on the back end. And I think that's where, as manufacturers, we should have some kind of standardized system for training our dealers, whether it's online or brick and mortar, because they're the ones that aren't really, they don't have access to things we have readily available. They may do it part-time, or they may do it, for other reasons, but the dealers that do it full-time, they should know and they should understand what they're selling that person or that customer or that company before they offer it, before they give the prices out. So I think this is a great example of how we can come together as an industry and set those standards for our dealers themselves.
And I don't necessarily disagree with that at all. I mean, the reality of it is, if we look around this room, Carolina Carports trained a lot of y'all, right? So, I definitely agree with having a very structured, standardized training process, and that's something that we try to achieve on a regular basis, is getting information out to our dealers as soon as it is readily available to us. It's whether or not they choose to actually communicate that to the customer that becomes the challenge, because it's the quick and easy money in the pocket and everybody can deal with it on the back end. So I think that, as we move forward, if this is something that's going to be entertained or become a regular thing, that we do need to get a lot more of the online dealers especially involved, because a lot of those guys are local and they're selling for all of us. They're not just selling for one of us. So I think that needs to be a big topic of conversation. One thing that Jay mentioned was, this price is here and this price is here. Well, that's kind of what we've got going on in this industry right now, and it's destructive, guys. Because if you can even the playing field at a 30% discount, then you can even the playing field at a 0% discount. And everybody can go back to the point where the installers make money, the companies make money, and there's a lot of business to go around. But this price war that is going on, the folks that are buying cheaper materials because of the price of materials going up and the fact that they're having to discount buildings, we know stuff is going out from our competitors that is not up to quality. And that's one thing that we're not willing to compromise. So, there definitely needs to be better dealer education, a standardized plan, some type of training that goes involved there. And the industry as a whole needs to take a step back and take a look at the fact that 15, 20%, 25%, 30%, 35%, up. Why? If you can even it at 20, then you can even it at 0. And that's just our opinion. And then at that point, maybe you can afford to not have to take on the customer that refuses to get a permit. Then you can pick and choose your battles like we do, so that we can make sure we maintain compliance.
I think that an association would be great. I'm really in favor of an association, not just a county, but a national association, because then everybody's on the same page, right? So buildings are not apples to apples, right? Along with Carolina Carports, Carports does not do barn doors. Why? Because we don't have the team. I understand that you need an architect. You need more to it for a barn door. And the last thing I want to do is have a soul die underneath that building, right? That's not the liability that we want to take on at this moment. But I think if you do an association, that would be awesome. Why? Because then the packages, what you sell would be similar, right? So on our price sheets, I don't know about the rest of, with the exception maybe of Carolina, have my published price sheets on the website, right? I have risk category 1 price sheets, right? So the customer is informed. I think that teaching our dealers is very important too. I have sales reps on the road that are constantly calling the dealers and seeing how the dealers are training the dealers. We've made video productions on Vimeo that are dealer training series, so they can learn about the loads and wins and how the price sheets are put together, right? They're all based on our engineering packages, right? So all of these are important steps to take. The ASC website, we check it on a regular basis to make sure that the drawings,
Absolutely.
the loads are right, and they're not always right, right? You look up a load and then call the local municipality and say, no, this the wind is higher, the snow is higher. Whatever that might be. So I think that a national association of tubular buildings or whatever is a great idea, and I would be very much on board for all of us to be on the same page, and make sure that we all use the same materials for our customers.
I'd like to kind of parlay on that a little bit. It has to start somewhere, and it can start here. And it should start here because Raleigh is looking to Surrey County because Surrey County is where it all began. And the nation is looking at North Carolina, and we can lead. It can be just maybe a collaboration between some of the manufacturers. We've got representatives from quite a few manufacturers here. But what I would love to see is something similar to the MBMA that governs the PEMB industry. Something similar to that, because once that criteria is established, one of the reasons that we see undercutting going on is because of the use of inferior materials. I hate to say it, but sometimes inferior design, and for other reasons. But having a standards organization would minimize that. It'll never get rid of it 100%. If someone's intent on doing wrong, they'll find a way to do wrong. But it is a start. And similar again to what I mentioned earlier, that if a county procures a building, or a state procures a building, or the federal government procures a building, the engineers and architects that are on that project are going to specify an MBMA certified building or MBMA certified manufacturer. That way, it's met these minimum criteria, and it puts everybody on the same playing field as far as how they make their buildings, QA/QC, and install the buildings, and so on and so forth. But we have, I kind of look back out at you. I'm going to kind of reflect your question back out, or your comment back out on you. You guys are here, and it's just a matter of y'all getting together and coming together to establish some type of governing organization. And I certainly hope it happens and happens quickly.
Wayne, I do have a question while you have the mic. I know there was a brief touch on master filing, which years ago in the state of Florida, almost every county you could master file in. Now there are 4. They have stopped allowing master filing because of the fact that many customers were walking in and saying, I'm buying a Carolina Carports building. Our plans are already on file. Then they get the guy down the road to put the building up. It fails inspection. And then that comes back on Carolina Carports because our plans are on the hook. So in Florida, the majority of the counties that were allowing master filing are no longer allowing that. So I don't know that the master filing is going to be a wide span accepted opportunity throughout, at least that we do over half the nation. So, I don't see that happening in all the counties. In that respect, how can we better protect our plans? Because our plans, there's a lot of companies that have tried to utilize, or customers and companies, dealers, that have tried and even in some cases successfully utilized our plans.
That is a terrible problem that the industry has. And the stealing of plans from those companies that are trying to do it right and paying an engineer to develop those types of documents. And then you have this intermediate dealer level that get their hands on these plans, and some of them are not very ethical. And plans just find a way of finding, going where they shouldn't go. And then we have seen our company name cut and pasted, removed or cut and pasted. I've actually seen my seal cut and pasted and placed on documents. That's a great question, Heather. Unfortunately, I've talked to the engineering boards about this, but similar to what I heard earlier, they don't have any jurisdiction over unlicensed folks, and so what we find is, again, with the dealers really not having any licensing, or certainly a homeowner, if they should happen to do it. I've even had churches do it. They can't police anything. They can send a nastygram that might have some impact, but civil action has really been about the only thing that companies can do. Unfortunately, the damage has been done, and the cost of the legal process is maybe not worth it. One of the reasons I'm suggesting that calculations be submitted along with the drawings, but only put in hands of the building officials only, is to prevent someone from coming in with a set of plans that might have been pirated and possibly modified, but they don't have the backup. There's no calculation backup to that. That's a red flag to the municipality. Don't issue permit because there's suspicion about that package. And of course, the fabricator, if they're on some type of roster, if they're there, wonderful. They've gone through that process that I talked about. If they're not, they haven't. And once again, the permit should be held up until that happens. But unfortunately, I don't have a good answer, for what's going on with the plans.
So, kind of bridging off of that, also a lot of these smaller mom and pop companies, and I know that everybody's tired of hearing about COVID and everything, but COVID really did impact this industry significantly. When it first started, everyone held their breath and thought, is anyone going to be buying a carport or a building? And the exact opposite happened. The market absolutely blew up. And that gave the leeway for all of these smaller mom and pop type companies to pop up who thought it was real easy to buy material down the road and go install carports or start small manufacturing facilities or whatever the case might be. But in those cases, those companies failed to license and register and, gain a contractor's license. And then you have other companies who might have those licenses that are basically leasing those licenses out to other companies. And so you never really know who built it, who didn't. And so how can the state, how can the county step in and help make sure that these companies are properly registered, that they are licensed? We have alerts that pop up every single day. Every time certain keywords pop up or there's a new carport registration or a new carport company that develops. And we can look those up till day's end and they are not licensed. So how can the county, the city monitor that better or force that?
Heather, I think that would be a better question answered by maybe possibly even Keith.
Well, what we, Surrey County, we see your drawings pretty much every day. So we see them enough to know that there's something right, okay? If we can see a photocopy, whatever, we get an idea. Just like I told you earlier, we had 2 companies use someone's drawings that no longer in business.
Yes.
And what we do, and we're out here to protect your industry as well too, because when we catch it, we're gonna stop it right there. And we're gonna notify you if someone's using your drawings, we are. And engineers and designers, I'm gonna send the drawings to you and tell you who done it, and at that point, you can get your lawyers to do whatever. But we're watching. We're watching closely because we know they're everywhere. And, you know, if you see something, tell us. We'll go out there, we'll visit them. We're complaint driven. There's only 5 inspectors covering this county, okay? And including me, and I don't get out of office much, but if we know, we get a complaint, we're gonna go check it out, okay? And you know, that's where we gotta communicate together in this industry. We're gonna help you, and we need your help as well too. And that's where I was talking about, it's a partnership, and we're gonna help you. It is a problem, and we will catch it. I don't know, but that's where, again, if we get together and talk about this, we can start setting guidelines here that covers your concerns, my concerns, and inspection department, and it starts here, we can grow. And that's kind of where I'm at with that.
But guys, until you, I'm from an inspector standpoint, until you assign those generic drawings to each individual job with a name, all the specifications, the loads, everything to it, you'll never stop this. Because they come in with a generic drawing, Keith, is that not correct? You don't have a name who it goes to anybody. And as long as it's done like that, you can never control it.
Yeah, so actually, we already do that. Even what we call generics, and I think what you guys have kind of been calling masters, with our generics, it always has the customer name and the address listed. However, there are old copies of all of our plans floating around out there that just simply get into the wrong hands.
Here's another idea, and I mentioned this a couple times when I met with some of you. If you want to email the drawings to us, instead of having your customers bring them to us, that way we know. Okay, you can say this is for John Doe on Miller Street, blah, blah, blah. That's a simple email. It's still the master copy, but you're giving a name to it, and that way it's not getting out in other people's hands. And you know, that's where we can always minimize it getting out of hand. Now, again, with I'm going to go ahead and say this, with installers working for several different companies, it gets things a little sideways with us too, because we can't keep up with who's working for who. And that's another reason why your drawings are getting pirated around, because they're moving around. And it's hard to control it when you're using independent installers. So that's just one thing I see from the outside in.
We do put those names on all of ours now, so that, you know, that certainly has helped the situation. It's just a matter of, like I said, there's still older sets of plans that are out there floating around.
Again, and most of the designers that I've spoken with, you know, you have to renew them every year. So if we see something that's 2 years, 3 years old, I'm gonna probably call that designer and say, hey, if you allow them to keep using these 2 or 3 years old. We're here in Surrey County, like I said, we've been seeing it, and we buckled down on it because we know it's a problem, and we're working on it.
So what are consequences? I mean, there's people using drawings from different companies, and I get it, we have to report it, and when I've gone through the process myself, nothing
happened.
done. So, you know, I got to the point where I get it, and it's, what do I do now? Do I just send a cease and desist letter to the dealer, or install whoever's using it? It doesn't go past that.
And we've all been victim to it at some point. If you're a manufacturer, you've all had this happen to you.
And not to build on that, now the dealers are victim to it. In this very conversation, we said dealers need to be better informed. They need to be more knowledgeable. They need to do a better job explaining it to the customers. Me, I've been in the industry 15 years. I've worked for Heather. I've worked for Gabe. I've worked for this gentleman. Currently, I work for myself, selling the buildings. And that's the reason I'm here. I want to know if a change happens in our industry so that I can represent it to my sales staff and then correctly to the customer, because I care about getting it right also. To lead off what Heather said, whenever you start having dealers or crews or other manufacturers that steal her plans, now she becomes very tight with her plans, and she doesn't even want to share it with me, her business partner, because she's not sure if she can trust me today. Maybe today she can, maybe tomorrow she can't. Maybe she raised her price $5 and I don't like it. And this one doesn't have plans, and the next thing you know, the dealers start slinging these things all over the neighborhood. There's even been a company at one point that was set up just to hand plans around the industry. So now I've got guys like in this very room right now that I represent, some of what I consider to be the most reputable. They won't show me their plans, which means I can't even tell the customer how to pour their concrete correctly. I can't tell him the depth. I can't tell him how much rebar's got to be in it, whether it has to have gravel, underlayment, rebar, none of the above. I'm blind, and I've been kept blind to keep me from harming the manufacturer that I represent. So in this conversation, it's been said that the manufacturer needs to pull the permit. Well, the first part of the permit that has to be inspected is the concrete pad. Is now the manufacturer of the building, who's just manufacturing and delivering the building, on the hook for errors made by the concrete professional? I'm not sure how that would work, because from my perspective, I've got to figure out how to get all the ducks in a row to make sure everything's done right based upon what decisions get done here. A regulatory agency over this industry would be an absolute godsend and a blessing. Everybody here would benefit from it. There's so much that we could improve upon, but we also have to keep in mind what made our industry the success that it is. People can afford to put our product in their backyard when they can't afford to put anybody else's product. I'd rather have a Range Rover. I can't afford it, so I drive a Chevrolet. That's the point to our industry. Everyone would rather have a Red Iron, a Mule. They're better buildings. Somebody argue with me. They can't afford it. So the dream's the harbor, not the building going over the harbor. The customer's just looking to get that bass boat protected as quick, cheap as possible. And we all have to figure out how to work together with the customer, with the county, to make sure that all happens in an expeditious fashion. Not sure if I have a question or statement.
Yes, sir. I want to tag on what you said a while ago. We're trying to be a little more proactive too as far as enforcement of this. But one of the things, and I know we're talking a lot of manufacturing here, but that dealers, I think, is where it's coming from, and that is that, you know, I can count you numerous people that's come into my office and said that when we asked them for a set of engineered drawings, they say, well, the dealer told me that it's this price if I don't have engineered drawings, this price if I do have engineered drawings. You know, that's a big problem for us to deal with there. And I'd like to ask a question if,
Go ahead.
I guess Curtis, this is going to go back to you, but and I think I know the answer to this, but say I've got a customer that's got a project's $39,900. Do they have to have a contractor's license?
That's the cost of the undertaking.
The cost of the undertaking.
Everything's there. If it's $39,999, no licensure.
No license.
Yeah. And which means, guys, there's no regulation for any professional to do the job. Okay?
That doesn't mean that the customer doesn't have to pull a permit, just that they don't necessarily have to have a GC.
General contractor license for cost of the undertaking.
So, Hank, I've got a question. I was in the wood building industry for 42 years. You guys regulate the hell out of us. We have empirical designs for this, empirical designs for that. Are you guys actually thinking, and I respect everybody in here for what they're doing, that this groundswell is going to eventually come to you guys before the POI or before the Codes Commission puts together codes and requirements for them? I'm stunned but I'd used it too before, it was stamped. These guys don't have to have stuff that's stamped, and you're not putting that regulation out. The state's not regulating. Don't get me wrong, I don't want to be regulated as much as anybody else does. But it sounds to me like this is kind of working semi-reverse, that you guys should be not just looking for them to give you information. You should be seeking out things in the industry to find out where the reality is as far as the materials that they're getting. Somebody's got to regulate what they're getting and where they're getting it from.
Well, again, I mean, in all our presentation, you kind of realize that, I mean, this type of building, it is not under the prescriptive code.
Exactly.
So, I mean, the 2x4 is, so that's why the 2x4 has to meet all these requirements from the code. But again, now your metal building, we don't have that regular regulations or guidelines or code requirements from the codes
The
there.
question is, why not?
Well, we have that in the ICO, actually. Cold form steel is part of the sessions in chapter 5, probably chapter 6 too. Our ad hoc committees from the previous edition ruled that cold form steel was removed from the North Carolina building and the residential code. The reason is it is not I would say, not a common construction method in the state. So that's why right. But again, I mean, things change. Things change. Every day. And now I think it might be a better time to, review that, to see that should be going back to the North Carolina residential code. Again, you can always use the international code as an alternate method if you need any information from that code to associate with your project, if that is covered in the international building code.
So when we designed the codes and the ordinances for us stick builders back in the day, you guys brought in other builders. This is an excellent group of people for you to bring into Raleigh and put together some type of group of people to say, we're going to help you and guide you and give you some strength and some power from our state, not just from what these people are doing.
Are you suggesting maybe Woodstock, don't mean to jump in, but, and I may not be, but Pike talked about the residential code being prescriptive.
Mm-hmm.
And as you mentioned, it's just a cookbook.
Yeah.
It says this is how you do.
Yeah.
And I think what your question is, or maybe what you're thinking about is that it may be beneficial to see a prescriptive code installation for metal buildings.
Ask them.
Sorry?
Ask them. I'm not a builder, but I think if you ask them, they'd like to see some guidelines that they know they all would have to go on.
Right.
Because what I'm hearing is, builder here is doing this, designer here is doing that. Some prescriptive compliance for them, I think would help, at least.
Yeah, I think it would definitely be beneficial. I know Gio's sitting here with me. He manages our permitting department. We have plans that go out, buildings that go out, and the building is built perfect to the plan. But the inspector has his own interpretation, so he wants a little more here or a little more there. He wants an extra anchor here, or he doesn't like the fact that the anchors are under the uprights of the end wall. And so a lot of times we end up trying to navigate things that we've legitimately done correctly. But unfortunately, because there is no standard, even the inspectors themselves, we challenge every day because of their interpretations, especially with the generic plans, not so much the site specifics, but because they don't have a clear understanding of where this industry falls in terms of regulation.
Additionally, I think the stick build industry is a little different than the way our industry works in that Weyerhaeuser manufactures the 2x4. They ship that off Lowe's, Home Depot, Parker's. XYZ contractor walks in and picks that up. Weyerhaeuser has no dog in the contractor's fight. So you can rest assured the contractors or the Weyerhaeuser's going to make that 2x4 spec. So Weyerhaeuser doesn't get their hands smacked. In this situation, the contractor is literally whittling the 2x4 themselves. So there's a separation in that we're buying raw materials and then forming it into finished goods in many situations. The two most vocal in the room do that. Others buy it from a third party. So couldn't a regulatory organization like, say, Keystone, for example, come in and do spot checks on this material from everywhere that's manufacturing the material to help make sure, because now Keystone has no dog in the fight of ABC Carport Manufacturing Company. Wouldn't that be the easiest resolution to that issue, to make sure that a neutral third party had vetted it?
Yeah, we go through a Keystone audit every single year of our lives with our 26 gauge material in the state of Florida.
Absolutely.
So it is, there's the ability to do that, yes, we do it every year.
As well. And then as long as the engineering that you guys had designed, now correct me if I'm wrong, if you say we're building this carport, this garage out of metal XYZ, thickness, tensile, components, whatever it is you guys, maybe get a metallurgical guy in here too, and whatever it is you guys need the building made out of, can't we just test it to verify that that is what's being used at each facility?
Quite a bit has been raised up from the initial question raised by the gentleman over there, but if you'll note, well, first off, the design engineer, again, as part of their analysis process and part of the design documents that they generate, should clearly specify the type of material that's being used in the analysis. That engineer is assuming, for instance, a 50 KSI or a 52 KSI or a 54 KSI yield strength. They're also specifying an ASTM standard that material meet. Now, how do you ensure that that gets into the building? Well, you guys mentioned that you use a third-party peer review, Keystone. Okay, that is certainly a way to make sure that the materials that you are receiving and using in your buildings meet that requirement. That is also part of that registration process that I talked about that the City of Houston implements. And that is, again, a third-party reviewer making sure that if Carport Company X, in their QAQC plan says that they're using that type of material, that it doesn't get substituted with a 33 KSI material, or if the engineer has assumed 12 gauge, that they're not using 13 gauge material, or something along those lines. It boils down to QAQC. The larger companies are doing a pretty good job of trying to maintain their QAQC. We're not seeing that in some of the middle-sized companies and many of the smaller-sized companies. They can get there certainly, but right now we are seeing that unlevel playing field. And at least from the design engineer standpoint, and possibly the erector being a licensed general contractor, trying to level and assure good QAQC.